The night beyond the outer planets did not darken. It thinned. Starlight, scattered through a veil of charged particles, took on a clarity that human eyes had never owned. A small machine, no heavier than a quiet motorcycle, listened to that thinning. It carried clocks that kept better time than human memory, antennas that could taste the slight salt of electrons, and a stubborn patience fitted for distances without walls. The sun still warmed dust millions of kilometers away, but here the warmth arrived as rumor, a waning pressure, an ebbing breath. The spacecraft felt it first as a change of weather. The familiar gust of solar wind softened. The speed of those streaming particles fell as if the road ahead were uphill. It was not uphill, it was outside. Every engine of planets, comets, and light began at the Sunday. The tiny traveler had spent decades skimming that engine's wake. It had woven around the giant orbits, ridden slings of gravity out of the inner glow, and entered a region where the home star's pride could no longer pass itself off as rule. Here, the sun was a local custom. The galaxy kept the law. The craft did not see a border painted in space. It saw a pattern break. Measurements that once swayed with the solar cycle steadied, like waves settling after a storm. Other numbers rose with a serenity that felt almost stern. High-energy particles from the galaxy came faster and without apology. The count ticked higher, as if some door had been opened in a hallway and a colder draft had found its way in. No one had ever walked to this hallway. The mapmakers on Earth had drawn its suggestion with cautious lines and mathematic air. They called the region around the sun a bubble of magnetized wind that pushed against the local interstellar medium. They knew that somewhere that bubble lost its argument. The name for that losing was the heliopause. The craft did not know the name. It knew the feel. It knew the murals of charged particles changing on its detectors, one color fading, another advancing. It knew the whisper of plasma oscillations vibrating the long wires it trailed, a whisper like a finger drawn along the rim of a glass. From that hum, a density could be heard, a temperature inferred, a boundary sensed through sound that had no air. Imagine standing at the mouth of a cave, sunlight behind, night ahead, and a wind that no longer carries the scent of home. There was no scent here. There were numbers, and the numbers told a story of two airs meeting. On one side, the sun's wind flung outward, hot and quick, its magnetic field coiled by the star's rotation into a spiral. On the other, the galaxy's thin gas drifted, older than any single star, threaded with fields born in supernova husks and stretched by the turn of the Milky Way. The craft felt the tug of both. It was not a tug on its body, but on the currents that grazed its senses. In that feel, scientists learned that the universe could have weather finer than any sky, and that a boundary could be neither a wall nor a fog, but a negotiation that never finished. The negotiation had taken billions of years. The sun's wind had inflated its domain since the star began to burn, and the interstellar medium had answered with its own pressure, its own magnetic insistence. Where they met, a drape formed, a sheath of altered plasma, compressed atoms, and fields that chose a direction slightly different than forecast. The spacecraft became a messenger for that difference. It carried the cool astonishment of a compass that did not swing as dramatically as expected. It reported a rain of galactic cosmic rays that increased as if the roof had lifted. It recorded a drop in lower energy solar particles that felt like the closing of a door behind it. Each change arrived, not as spectacle, but as a steadying truth. The frontier was real, and it was close enough to measure, yet far enough to remain a poem of physics rather than a landscape. No poetry can replace the patience required to hear a whisper across almost 20 light hours. The spacecraft spun its faint voice toward a blue planet and spoke in bits carved from radio. On Earth, dish antennas the size of small arenas cupped that voice from space and rebuilt it into lines of digits. In those digits lived the drama. The sun's particles had traveled outward in a supersonic flow, then slowed at a termination shock where the flow thickened and heated. Beyond that shock lay the heliosheath, a turbulent buffer that felt like the backwash of an oar. In that buffer, the craft had bobbed for a time. Then, without ceremony, the character of the sea changed. Galactic particles, long held at bay by the sun's bubble, seeped in with confidence. The pressure of solar wind fell below the pressure from outside. The heliopause had been crossed. The words used to describe this moment cannot help but sound human. Crossing, outside, beyond. The reality was both simpler and stranger. A plasma of protons and electrons, so thin that a cubic centimeter might hold a handful where Earth's air holds trillions, had become thicker by only a little. A magnetic field shifted its mood from spiraled solar to draped interstellar. A drizzle of radiation hardened into a steady rain. The craft was still in the sun's gravity. It would be in that gravity for a long time. It was still bathed in starlight from every direction. Nothing exploded, nothing flashed, yet the change mattered more than spectacle. It said that human instruments had entered the galaxy proper, not in idea but in measurement. There is a modesty to such milestones. The spacecraft did not look back. It continued forward, carried by momentum and the curve of a trajectory set in a decade of disco and unrest. The boundary did not care about decades. It breathed with the sun's 11-year cycle, swelled with coronal mass ejections, and wrinkled where knots of interstellar magnetism pressed. The craft caught only a slice of that breathing, a single crossing in a living border. From that slice, a library of inference grew. The thickness of the sheath, the angle of the fields, the way cosmic rays of different energies threaded through the drape, some finding easy passage, some rebuffed. The heliosphere, once imagined as a comet-like shape, began to look less like a simple tear and more like a pressure sculpture, pushed by flows that did not stream politely. To stand at a window on Earth and think of that sculpture is to accept scale as a form of prayer. The heliosphere holds every world known to a species that names things. It is a bubble so large that light takes a day to cross from sun to edge, and yet it is a trivial puff compared to the galaxy. The little traveller did not carry a camera for this part of the trip. There was nothing to see, only much to hear. It heard the sun recede in authority. It heard the galaxy clear its throat. It heard the difference between a breeze made by a single star and a draft made by millions of years of accumulated explosions, rotations, and cold patience. Not even silence is simple in such a place. Silence here is a contest between weak fields and rarefied gas, between the relic winds of a young star and the settled currents of interstellar space. If there is a lesson in that contest, it is that borders in nature seldom deserve a line. They deserve a story. The spacecraft became a sentence within that story, a clause that turned when the subject changed from solar to galactic. In turning, it offered a first taste of the outside. The taste was not exotic. Hydrogen, electrons, magnetic fields, the same ingredients written in a slightly different grammar, yet by tasting, it made the outside real for the minds that had only imagined it. It suggested that home is not ended by an edge, only translated into a larger dialect. The sun did not stop at the heliopause. Its light continued, its gravity continued, its history continued. What ended was primacy. Beyond that place, the sun shared the stage with tides that owed nothing to it. The craft did not celebrate. It logged another point, another count, another tone from its plasma antenna and moved on. The celebration belonged to a species that had learned to listen across gulfs. They listened and discovered that beyond the solar neighborhood, the galaxy was not empty. It had texture, pressure, temperature, and shape. It had a pulse that could be timed by a machine that ran on the soft glow of decaying atoms, a machine that had grown old but not tired. That machine had met the first weather of the galaxy, and from that weather it drew a map not of continents but of conditions. The outside began to feel less like an abyss and more like a sea, and a sea never ends at the edge of a pier. It extends, with rules that can be learned, and with mysteries that reward the ones who go far enough to feel the wind change. The discovery began with a geometry lesson. In 1965, a young trajectory analyst noticed that the outer planets would gather into a rare arrangement during the late 1970 seconds, a slow parade that would allow a single spacecraft to fall from one giant's gravity to the next, like a stone skipping across dark water. Mission designers turned that alignment into the Grand Tour concept, and a name that fit a stricter budget took hold. The spacecraft would be called Voyager. Engineers at the Jet Propulsion Laboratory drew a bus-sized machine with a dish as its face, a long boom for magnetometers, and fragile wire antennas to feel plasma waves. The launch site was Cape Canaveral. The rocket was Titan III with a Centaur upper stage, a workhorse that turned thunder and ice into escape. In August and September of 1977, two vehicles rose from the Atlantic coast and began a long throw that targeted a frontier no telescope could see. They were built for the planets, yet each carried instruments that would outlive the portrait work. The magnetometer, perched far from the spacecraft to avoid contamination by its own fields, would read the strength and direction of invisible lines. The plasma wave subsystem would listen to natural radio tones that reveal the density of charged gas. The low-energy charged particle detector and the cosmic ray system would count messengers from the Sun and the galaxy across a wide range of energies. The ultraviolet spectrometer would taste the thin glow of hydrogen and helium. Power came from warm bricks of plutonium dioxide sealed inside thermoelectric generators. Guidance came from a blend of star trackers, gyros, and ground control. These machines were not aware, but their patience had been designed by people who understood that time in the outer dark would be a better ally than speed. The first act of discovery was classical exploration. Gravity assists swung one craft past Jupiter in 1979 and Saturn in 1980, then tipped it toward the north of the ecliptic. The other craft threaded past Jupiter in 1979, Saturn in 1981, Uranus in 1986, and Neptune in 1989, then headed south and outward. Cameras shut down once the planetary portraits were complete, saving power for sensors that did not need light. A new kind of mapmaking began, one that measured the sun's breath rather than color. The region far beyond Neptune is filled with the solar wind, a supersonic stream of plasma that carries the sun's magnetic field outward. That wind is not infinite. It slows where the pressure of the interstellar medium pushes back, passes through a termination shock, and stirs a shell called the heliosheath. Somewhere beyond that shell lies the heliopause, where the sun's influence yields to the galaxy. The Voyagers would not see it with cameras. They would hear it with instruments that count and hum. Key voices of this effort had become steady fixtures in control rooms and conferences. The project scientist, a calm interpreter of turmoil in the data, coordinated the diverse teams and kept the questions honest. The magnetometer team, heirs to a craft of measuring whispers, watched for any decisive swing in field direction. The cosmic ray and low-energy particle teams, veterans of space weather and nuclear tracks etched in detectors, traced the rise and fall of radiation from both solar and galactic sources. The plasma wave group, led by a radiophysicist with a musician's ear, tuned to emissions that occur when charged particles oscillate and ring-like struck crystal. The plasma instrument on one spacecraft had fallen silent in the 1,980 seconds, but the plasma wave subsystem remained, able to estimate density indirectly when a solar storm sent a shock through space and made electrons sing. The second spacecraft kept its plasma instrument alive, a gift for the day when numbers would need confirmation by direct taste. Discovery crystallized through patience with small changes. As the first spacecraft drifted into the heliosheath, counts of lower-energy solar particles fluctuated in eddies, while higher-energy galactic cosmic rays crept upward. The magnetometer drew lines, showing field strength increasing, a sign of compressed plasma as the wind slowed. Years passed in this thickened sea. Then a sequence arrived that felt like a verdict. The galactic cosmic ray intensity jumped and stayed high. The solar particle counts fell and remained low. The local magnetic field strengthened sharply, yet the field direction refused a dramatic pivot. That puzzle delayed any pronouncement, because many had expected a clear rotation when crossing from solar to interstellar domains. The hesitation was resolved by a sound that could not be faked. The plasma wave subsystem heard a tone that matched the electron plasma frequency in a medium far denser than the solar wind. The inferred density fit the expectation for the local interstellar medium rather than the heliosheath. That tone, produced when a solar shock passed and set electrons oscillating, acted as a tuning fork for the void. The team concluded that the spacecraft had moved into interstellar space, a scientific landmark anchored not in rhetoric, but in calibrated hum. The second spacecraft repeated the long test along a different path. It had approached the boundary from a southern latitude, carrying the advantage of a working plasma instrument. The heliosheath there showed its own texture. Particle gradients rose and fell along different slopes, magnetic pressure behaved with its own rhythm, and the field again strengthened. When the moment came, the same duet of signs played out: a decline in solar particles, a surge in galactic ones, a stiffening of magnetic field, and this time a direct measurement of cooler, denser plasma beyond the boundary. The data confirmed the conclusion that had once needed inference and contradicted any simple picture by showing a different profile of change. A living frontier revealed itself through two distinct entries taught by parallel instruments guided by geometry rather than spectacle. Ground on Earth made the discovery possible. The Deep Space Network, with dishes at Goldstone in California, near Madrid in Spain, and near Canberra in Australia, stitched a continuous ear around the turning planet. Technicians coaxed faint signals through interplanetary static. Engineers compensated for the drift of aging oscillators, the weakening of generators, and the slow loss of heat. Each downlink delivered strings of numbers that would later be colored into graphs on screens. Students learned to see a boundary not as a line, but as an ensemble of correlated trends. Rising cosmic ray counts meant one thing alone, but together with a fall in solar particles and a jump in magnetic pressure, they meant a door had opened. The plasma wave tones added the signature that sealed the impression into fact. The discovery also relied on memory, not of stories but of calibration curves, sensor quirks, and the history of solar storms. When a coronal mass ejection left the Sun, space weather centers tracked its shock as it traveled outward, evolving into a wave that the spacecraft might later hear. Months or more could pass between origin and arrival. Predicting those arrivals allowed the plasma wave team to anticipate when the interstellar medium might ring. Hearing that ring at the right frequency turned a suspicion into a measurement. On the second spacecraft, the plasma instrument read the speed, density, and temperature of particles more directly. Those numbers were cold enough and slow enough to say that the craft had truly entered a medium shaped by the galaxy rather than the Sunday. The how of discovery was quantitative, but the where and when mattered to the imagination. The first crossing occurred at a distance more than 100 times the span between Earth and the Sun above the planetary plane. The second occurred years later, at a similar range but below the plane. The heliosphere, once drawn like a smooth teardrop, now seemed lopsided, maybe pinched by external magnetic fields, maybe bloated by internal pressure. The timing of each crossing echoed the solar cycle, hinting that the border swells and contracts with the star's moods. The alignment of planets that had yielded the launch opportunity now yielded a topographic map of a boundary that breathes. Who discovered it can be said simply, yet the truth is a chorus. Mission planners who saw a window in celestial mechanics made the throw possible. Rocket builders who married cryogenic stages to guidance computers gave the throw strength. Instrument teams who designed detectors for both nearby planets and distant plasma gave the throw memory. Scientists who refused to rush a conclusion listened long enough to let weak signals become conviction. The two spacecraft themselves, machines without vanity, became the quiet hands that pulled back the curtain. The result was not an announcement of conquest. It was the naming of a place by measurement, a place where the pressure of our star yields to the long-settled drift of the interstellar medium. The discovery phase did not end with a headline. It matured into the daily work of tending instruments, choosing which bits to send, and revising models with each trickle of evidence. It taught a method for detecting a boundary that cannot be seen, a method transferable to other draped borders in astrophysics where magnetic fields and thin plasmas negotiate power. It anchored the word outside in a set of numbers rather than a mood. It showed that a spacecraft designed in an era of analog televisions and paper printouts could learn to speak the dialect of the galaxy, one note of plasma song at a time. There is elegance in that kind of discovery. It favors no bravado and asks only that an ear remain open longer than doubt. The surprise arrived in measurements that were not supposed to agree with one another. A boundary had been anticipated where the sun's spiraled magnetism would yield to the galaxy's wider field, and a clean rotation in direction would announce the change. Instruments were tuned for that pivot. The moment came, the pressure rose, the counts of distant radiation surged, and the lower energy breath from the sun fell away. The magnetic field strength stepped upward, as if a tautness had replaced slack. Yet the compass in the data did not twist as the sketches had insisted it would. The field lines continued to point almost as before, a quiet defiance to tidy expectations. Shock has many styles. This one was quiet, numerical, and stubborn. The count of galactic cosmic rays carried the first astonishment. Particles born in ancient supernova debris and accelerated by tangled fields had been partially excluded by the sun's outflow. At the boundary, that exclusion weakened. Monitors that had spent years recording a gentle climb suddenly claimed a high plateau. The increase was not a blink. It held. At the same time, energies characteristic of the sun's wind dropped by orders of magnitude, as if a door had been closed on a familiar hallway. A physicist's intuition would label such paired changes as confirmation that the spacecraft had entered a new regime. But the magnetometer refused to endorse this with a dramatic turn. It reported a stronger field whose direction drifted by degrees rather than swinging by a compass point. In conference rooms, diagrams were erased and redrawn with a patience that did not conceal surprise. The next astonishment came as sound. The plasma wave sensors were ears to the electron plasma frequency, a natural tone set by electron density. When a shock from a distant solar eruption passed the spacecraft, electrons in the surrounding medium were jostled into oscillation. The frequency of that ringing revealed a density far higher than the rarefied solar wind. The implication was that the craft was swimming in the local interstellar medium, a region with a number of electrons per cubic centimeter, consistent with a cold cloud that has drifted near for millions of years. Density told one story with clarity. Direction told another with ambiguity. The mismatch demanded an explanation that could keep both true at once. A concept emerged that softened the edge between domains. Rather than a crisp border, the region ahead behaved like a magnetic highway. Lines from the heliosphere appeared connected to those outside, forming channels through which particles could stream. In such a connection, solar particles would find escape paths outward, while galactic particles would find entry paths inward without immediate need for a strong rotation in direction. The spacecraft floated in lanes rather than rooms, and in lanes the flow is set by connectivity more than by address. The data supported this with anisotropies in particle arrival directions, as if a preferred orientation guided the traffic. The word porous began to accompany the word boundary. A shock of a different kind touched the models of shape. Many illustrations had shown the heliosphere like a windsock with a graceful tail stretching far downstream. Energetic neutral atom images and particle gradients hinted at a structure less like a single flowing tear and more like a pressurized shell with folds and wrinkles. External magnetic fields could drape around the solar bubble and sculpt it into a form with lobes and indentations, defying the old simplicity. Crossing profiles differed with latitude. The spacecraft that traced a northern path recorded thickness, turbulence, and gradients that did not match those along a southern path. The frontier displayed regional personality, like weather patterns that share a climate but not a forecast. The magnetic enigma persisted, even as confidence grew about entry into interstellar plasma. Field strength had increased to about half a nanotesla, a number appropriate for the local medium. The direction, however, continued for long stretches to align within tens of degrees of the heliospheric spiral. Researchers considered the draping of interstellar fields that bend around the bubble and run nearly parallel at the nose. In such a geometry, a sharp turn might not be required where the spacecraft happened to cross. Another possibility was reconnection, a process where lines of magnetic force break and join, creating portals that blend regions without a sudden change in direction. These ideas had existed in theory. The data put them on the table with new urgency. Temperature surprised as well. Where the solar wind slows and heats in the transitional sheath, expectations for the interstellar side had favored relatively cool plasma. Direct and indirect readings suggested electron temperatures that were cooler than the sheath but warmer than a simple textbook estimate, a hint that the boundary compresses and energizes particles in complex ways. Debates sharpened around whether the measured densities and temperatures implied a nearby cloud edge or an extended environment of mixed origins. Even the age of the plasma in that region became a subject. Was the craft sampling gas that had recently been shocked by a series of solar outbursts, or a calmer medium that only rang when struck by occasional disturbances? Time injected its own shock through patience. The crossing did not appear as a single spike, but as a sequence of step changes and plateaus. Measurements of low-energy particles showed sudden dropouts, then partial returns, then renewed declines. Cosmic ray levels rose, leveled, wavered, and stabilized. The magnetic field tightened, loosened, then tightened again. If a living frontier breathes, the graphs looked like breath. The expectation of a single, clean signature yielded to a recognition that multiple signatures must agree across days and months. The shock, then, was as much about method as about nature. The community learned to declare entry only when several instruments sang the same note in different registers. Comparisons between the two long travelers added depth to the surprise. The second craft approached the boundary with a functioning plasma instrument and found a rise in density that could be read directly rather than inferred from oscillation tones alone. The slope of the rise differed. The distribution of particle energies took a different shape. The magnetic pressure increased, then displayed a profile distinct from the earlier path. The shock here was not contradiction but complexity. The frontier behaved like a system whose response depends on where and when it is touched. Solar cycle phase mattered. External field orientation mattered. Latitude mattered. Each mattered enough to make any single crossing an incomplete sentence. Cosmic rays carried implications that reached back toward home. The increase beyond the boundary quantified the shield that the heliosphere provides. The sun's outflow modulates the intensity of galactic radiation that reaches the inner worlds. A stronger shield during high solar activity means fewer high-energy particles penetrating toward Earth and its neighbors. A weaker shield during quiet solar activity means a higher flux. The difference measured in the boundary's neighborhood gave weight to models of long-term radiation trends that affect everything from atmospheric chemistry to the reliability needs of spacecraft electronics. The shock lay in learning how strongly a thin, magnetized wind defines the safety of a planetary system. The termination shock itself, encountered earlier, had already hinted that the road would be rougher than a simple passage from fast to slow. There had been variability in how and where the wind transitioned to subsonic flow. The heliosheath downstream exhibited turbulence that looked like a sea under conflicting winds. The final steps into the interstellar medium gathered all these complexities and presented them as a continuously negotiated truce between pressures, fields, and flows. The absence of an iconic magnetic rotation became a symbol for the general lesson. Nature prefers gradients and negotiations to crisp lines. Each unexpected detail nudged theory into new shapes. Models began to incorporate field line meanders that allow particles to wander farther than standard diffusion permits. Transport coefficients received revisions to match the newly revealed behavior of high-energy messengers. Simulations of the heliopause grew finer and more dynamic, adding reconnection islands and rippled surfaces that change with the sun's rhythm. The initial shock matured into a working framework, but the first feeling did not fade. The data had quietly moved an old boundary from black ink to textured relief. The instruments that delivered these surprises did nothing dramatic to earn credit. They counted, hummed, and endured. Engineers on Earth tuned receivers, scheduled listening windows, and nursed power budgets measured in dwindling watts. From such care came the shocking calm in the numbers. A stronger magnetic field with nearly steady direction, a density that matched the galaxy, a radiation environment newly permissive to ancient messengers. These are small statements with large consequence. They told a story in which a border lets traffic through while still marking a change in law. The scientific shock did not close with a single explanation. It opened a set of questions that are answerable with longer listening and richer modeling. What proportion of the boundary is threaded by connected lines at any given time? How often does reconnection carve doors through the sheath? How thick is the region where properties blend rather than swap? Why does direction defy a theatrical turn in some corridors? The silence around those questions is not empty. It is full of data that must be taught to sing together. Surprise, in this case, is not a detour, it is the road. The deeper look began with a metronome made of storms. Coronal eruptions left the sun, merged into shocks, and marched outward through the thinning wind. Months later, those fronts arrived at the distant craft and kicked nearby electrons into song. The plasma wave antennas registered bright, glassy tones whose pitch revealed local density. Each tone was a pin on a silent map. One by one, the pins drew a profile of the medium outside the solar wind's domain. The numbers were small, fractions of an electron per cubic centimeter, yet they gathered into a curve that rose slowly with distance. The rise suggested that the spacecraft had entered not a void, but the edge of a larger structure where density gently increases toward the galactic side of the drape. The timing of the tones told a second story. The delay between solar eruptions and the distant ring set a clock for the journey of shocks through the heliosheath, then across the boundary, and finally into interstellar plasma. This clock became a ruler in time, and from it, researchers extracted the stiffness of the medium, its willingness to carry disturbances like ripples on a hard pane of water. Particle data deepened the scene. The instruments that count high-energy messengers settled into a new balance where galactic cosmic rays dominated at almost all directions. The gradient along the flight path flattened with distance, implying that diffusion became easier once the craft threaded beyond the sun's tangled outflow. Embedded in this new normal were small directional preferences that shifted slowly, as if long magnetic arcs guided the arrival of charged travelers. By comparing anisotropies across energy bands, the teams inferred that some field lines connected across the boundary, while others diverged into the wider galactic weave. The boundary looked less like a seam and more like a blend of braids, with strands that open and close as the sun's cycle changes pressure and connectivity. A different class of particles told a complementary tale. Anomalous cosmic rays, born from interstellar atoms that drift inward, become ionized, and then are accelerated near the termination shock, had been a fixture within the heliosheath. Beyond the border, their presence faded to a whisper. That drop confirmed a segregation of sources. The interstellar medium supplied the raw atoms, but the acceleration factory belonged to the sun's side of the curtain. The clean fall in this population, alongside the sustained rise of more ancient galactic ones, outlined the chemistry of the frontier. One side favors the birth and energizing of newcomers, the other receives visitors whose origins are scattered through distant supernovae and long magnetic journeys. Magnetic measurements, refined shape and tension, field strength remained elevated compared to the heliosheath, and showed quiet undulations that matched changes in particle propagation, a correlation that hinted at subtle compression and release. Direction wandered gradually rather than pivoting abruptly, yet small, sudden kinks did appear, brief episodes where reconnection may have opened a portal between regions. During such moments, the instruments sensed altered flows of particles, as though traffic surges through a temporary gate. The statistics of those episodes, scattered and irregular, suggested a boundary stirred by filamentary processes rather than a smooth surface. Computer models began to incorporate islands of reconnected field and ribbons of altered topology to reproduce the observed fits and starts. The plasma instrument on the Southern Traveler added a decisive flavor. It sampled the flow beyond the border and found it cooler and slower than the sheath, with speeds characteristic of a placid drift rather than a heated wind. The density agreed with values inferred by the radio tones from the northern path, bringing two distant measurements together without the need for an intervening argument. The measured flow direction deviated slightly from the craft's path, implying that the local interstellar plasma does not simply stream past like a river. It skirts the solar obstacle, bending around the bubble while carrying the memory of distant pressure gradients. That bend carried implications for the shape of the heliosphere's nose and for the way solar influences leak into the neighborhood beyond. Dust made a faint entrance in the data. Tiny grains rushing at many kilometers per second strike the spacecraft and release clouds of charged fragments that whisper into the plasma wave receivers. The rate and character of these pops changed with distance, hinting at a different dust environment outside. Models tied those changes to the filtering effect of magnetic fields on charged grains. Some sizes and charges are guided around the bubble, while others penetrate. The pattern that emerged supported a picture where the heliosphere acts as a sieve for dust, not just for particles of gas. This sieve helps set the population of grains that reach the inner system, where they influence zodiacal light and outer atmospheres. Radio silence, once a mystery in itself, became a clue. For decades, planetary explorers had occasionally heard long-wavelength radio bursts at a few kilohertz that were thought to originate near the interaction between the heliosphere and the interstellar medium. As the craft moved outside, those emissions did not thunder. Instead, the plasma wave tones remained the dominant sound. The absence of loud radio storms suggested that the boundary rarely hosts the fast, large-scale shocks needed to light it up at those frequencies, or that such shocks radiate away from the craft's path. When occasional distant radio episodes did flicker, their timing with solar activity back home strengthened the chain that connects eruptions near the Sun to responses many billions of kilometers away. Temperature emerged as a textured property rather than a single number. Electron temperatures derived from spectral shapes and wave damping rates indicated values that sit between cold clouds and hot shocks. The distribution of particle energies showed small departures from perfect equilibrium, a sign that the plasma outside remembers its recent history of compression and rarefaction. Those departures matter because they set how quickly cosmic rays scatter, how heat conducts, and how the boundary resists or admits traffic. The medium beyond is thin, but it is not naive. It carries scars that broaden lines in the data. Gradients in pressure told of a frontier that negotiates with its environment. By combining magnetic pressure, particle pressure, and thermal components, the teams built a budget for forces that hold the bubble in shape. The budget balanced, but not symmetrically. External magnetic pressure loomed large, almost equal to or exceeding the ram pressure of the local flow, implying that fields rather than bulk speed sculpt much of the heliosphere. That finding favored pictures where the Sun's domain is pinched into lobes at high latitudes and padded at the sides, a form far from a simple windsock. Subtle variations in field strength with latitude along the two paths supported this asymmetry. Even the slow drift of the craft through this medium became a tool. As it traveled outward, the sequence of densities measured by wave tones produced a gentle slope. When overlaid with the catalogue of solar outbursts that generated the shocks, the slope's shape implied that some waves steepened and dissipated in the sheath, while others crossed the boundary with resilience. The interstellar plasma responded more like a springy membrane than a brittle pane. That springiness sets the memory of disturbances, a memory audible in the way tones at slightly different times carried slightly different pitches even when the local sun was quiet. Software matured alongside the measurements. Simulations began to match not just single values but entire time histories, reproducing plateaus in cosmic ray intensity, dips in low-energy particle counts, and quiet periods punctuated by spikes of radio tone. Models that allowed field lines to wander in a way that exceeds standard diffusion came closer to the slow, even rise in galactic particle levels. Including reconnection sites created pathways that explained episodic leaks of solar particles beyond the formal border. Such additions turned broad theory into a finer craft, while the data challenged each embellishment with new details. Energy accounting refined the view of protection. By comparing spectra inside and outside, the integral of shielding provided by the heliosphere could be computed across energies relevant to electronics, human tissue, and atmospheric chemistry. The numbers demonstrated that the Sun's influence reduces the flux of many damaging particles by substantial factors that vary with the star's cycle. Seasonal forecasts of space radiation for deep space missions gained a foundation anchored in a direct sampling of the source environment. The boundary thus became not just a cartographic feature, but a safety device whose behavior could be measured and eventually predicted. The faint signal from the distant craft continued to serve as a sounding line. Each year added a few more tones, a few more steps in particle gradients, a few more whispers of dust strikes. The interstellar medium along that path revealed itself as calm, elastic, and threaded by fields that prefer alignment over drama. Complexity arrived in small increments, not in spectacles, and those increments accumulated into a portrait where the edge of a star's breadth and the beginning of the galaxy's patience coexist. The deeper investigation did not simplify the picture. It turned a border into a living region with character, a region that can be weighed, timed, and described with a vocabulary precise enough to teach and flexible enough to grow. Complexity gathered like frost on glass. The instrument spoke in plain numbers, yet the pattern behind those numbers refused a single story. What had seemed a clean transition from the sun's jurisdiction to the galaxy's quiet decree opened into tiers and corridors with separate rules. The frontier did not stay still. It breathed, tilted, shivered, and occasionally rearranged the order of events. Each change pushed models to pick up new verbs: drift instead of switch, blend instead of border, thread instead of wool. The first signal of deepening mystery came from timing that did not line up neatly. Solar eruptions launched shocks that should have announced themselves in sequence across the distant region. Some did, others arrived late, faded early, or skipped entire stretches as if a road detoured around unseen hills. The path of each disturbance appeared to depend not only on distance, but on which invisible magnetic rails were active at that hour. When rails shifted, the same class of shock traced a different fate. A clock that had seemed faithful now ticked with local accent, and that accent changed with the sun's mood and with the shape of fields the craft could not see directly. Another complication emerged in the way particles of different energies learned the terrain. High-energy cosmic rays treated the boundary as a screen with scattered pinholes, passing through with relative ease and smoothing out their gradients a short distance outside. Lower energy travelers behaved as if the pinholes closed and opened according to weather, sometimes streaming inward along one favored orientation, sometimes finding themselves deflected into a slow wander. The medium was thin, yet its rules were layered. Energy set social class, direction set opportunity, topology set law. A single crossing could not summarize that society. Magnetism deepened the riddle by appearing orderly on one scale and ragged on another. The average field direction drifted slowly across months, a quiet arc that inspired drawings of draped lines flowing around the sun's bubble. Within that drift lived brief knots and kinks where direction hopped, pressure hiccuped, and particles shifted their arrival preference. Those knots hinted at reconnection patches that stitched and restitched the fabric, but their frequency, size, and lifespan defied easy census. Some seemed to live long enough to redirect particle traffic for days. Others flickered like sparks. The frontier resembled a curtain caught in competing breezes, smooth from across the room and restless up close. Shape, once pictured as a simple windsock, now demanded an atlas of possibilities. If external magnetic pressure rivaled or exceeded the push of the local interstellar flow, then the heliosphere could wear high-latitude lobes instead of a grand tail. If reconnection carved channels selectively, leaks of solar particles might trace preferred longitudes. If the galaxy's field bent in a particular orientation, the nose of the bubble could be squashed and the flanks padded. Each if carried a distinct signature in the particle gradients and radiotones. The difficulty was not lack of data, but too many ways to satisfy the same surface facts. More than one architecture could explain the calm density increases, the stubborn near alignment of field direction, and the living texture of small kinks. The frontier became a puzzle with pieces that fit more than one picture. Dust sharpened the mystery in a quiet register. Impacts recorded by sensitive receivers suggested a change in the size distribution of grains outside the bubble, consistent with magnetic filtering. Yet the change did not track monotonically with distance. Patches appeared where the rate of hits stiffened or softened as though the craft had crossed faint streams of dust guided by fields, or born in ancient flows with slightly different chemical memory. Since charged grains respond sluggishly and carry histories measured in decades, their story overlapped but did not align with the plasma's faster tail. The same place held two timescales. The craft rode both, and the data pressed theory to reconcile clocks that rarely agree. Temperature refused to settle into a single temperature at all. Distributions of electrons and ions revealed gentle shoulders and extended tails where thermal simplicity would demand a neat bell curve. Those tails shaped how heat moved and how cosmic rays scattered. They also recorded forgotten chapters. A recent shock could leave a warm echo long after its driver had drifted on, while an older compression could bias the distribution toward cooler populations held together by slow collisions. The frontier kept memory in its temperature, and memory is always a negotiation between the fresh and the ancient. Even vocabulary began to fail the growing subtlety. Terms like inside and outside felt blunt next to the evidence for connected field lines, temporary portals, and braided corridors. The craft, still moving outward, sometimes detected particle flows that smelled of the sun in a region otherwise dominated by the galaxy, as if a vein carried sap past the bark. On other days, the same energy range refused any trace of solar origin, yielding a clean galactic spectrum that implied disconnection. The border behaved less like a fence and more like an estuary where fresh and salt waters mingle in shifting channels. Maps of an estuary change with tide and season. So did the maps of this electrically thin sea. Anomalous cosmic rays added a twist that stubbornly resisted a single cause. Their production near the termination shock should place their abundance largely on the sun's side. After entry into interstellar plasma, their counts dropped as expected, but small revivals appeared episodically, not large enough to overthrow the rule, yet strong enough to argue for intermittent leaks or memories of acceleration that extended farther than simple zones allowed. When those revivals coincided with minor magnetic kinks, the suggestion of reconnection as a gate grew louder, but not universal. Some revivals ignored any obvious magnetic sign, and instead followed distant solar activity after long delay. Ambiguity grew a second route, alongside correlation. The heliosheath itself complicated matters from behind. Its turbulence was not white noise, but structured. Eddies and compressions created pockets of altered diffusion that could steer the approach of both shocks and particles toward the border in ways that changed the subsequent response outside. One craft would see a crisp step, another a smeared slope, simply because the approach road differed. To explain the frontier, one had to explain the neighborhood upstream, and that neighborhood changed with the solar cycle and with slow changes in the sun's magnetic orientation. Power aboard the travelers fell by steady increments as their generators cooled with age, which forced hard choices among instruments and data rates. Those choices did not diminish discovery, but they shaped its accent. With limited bandwidth, long integration replaced rapid sampling. Subtle phenomena that unfolded quickly could slip between transmissions, leaving hints rather than full portraits. Ambiguity took advantage of such gaps. Models had to stretch over missing minutes or hours and decide whether to fill them with interpolation or with honest silence. Each approach carried risk. A gap that hides a reconnection flash could be mistaken for calm. A careless fill could invent a symmetry that nature never promised. Distance added another counterintuitive pressure. The farther the craft traveled, the closer its instruments came to the scale where neighboring structures blur. A knot several astronomical units across can be sharp when the sensor sits next to it. A few years later, as the craft has gone dozens of units farther, the same class of knot may be too small to extract from the background variation, even if it still exists. A frontier that once looked wrinkled can appear smoother simply because of perspective. Smoothing with distance is a deceit that every explorer must confront. The data forced modelers to ask whether quiet meant change in the medium or only change in the resolving power of a patient observer. The meaning of protection shifted as complexity mounted. The heliosphere shields the inner system from high-energy messengers, but shielding is not uniform. It evolves with the sun's cycle, with the geometry of external fields, and with the history of reconnection that has opened or closed lanes at the border. Forecasting radiation environments for deep space voyages now required a chain of models stretching from photospheric magnetism to heliosheath turbulence and finally to the braided motifs of the heliopause. Each link had to inherit the uncertainty of the link before. The frontier thus became not only a scientific mystery, but a practical one, since planning journeys depends on knowing which parts of the galaxy's weather the sun can temper. Perhaps the deepest complication arrived as a philosophical echo from the instruments themselves. The spacecraft measured what passed through it. It was a point sampler in a medium where geometry matters. Two paths across a quilt cannot define the whole pattern if the stitches curve between them. The very act of crossing along narrow corridors turned the data into biographies of specific threads. To compose a general physics from such biographies required a discipline that alternated between modesty and boldness, admitting the partial view while still risking a sketch of the whole. The frontier demanded that balance. Caution without imagination would ignore connections that the numbers suggested. Imagination without caution would write fiction on a canvas that deserved patience. Through all this, one clarity survived and grew. The heliopause is not a finish line. It is a set of interacting processes that create a semi-permeable contact between a star's breath and the galaxy's reservoir. Each process leaves signatures scattered across densities, temperatures, field directions, particle spectra, and dust pops. None of those signatures is privileged enough to rule alone. Only their chorus makes a frontier. As the craft pressed on, that chorus changed key and tempo, not wildly, but gently and persistently, insisting that the edge of a star is a living thing shaped by distant pressures and local quirks. The mystery deepened because it could be measured so clearly and yet refuse any single, permanent frame. The result was not confusion. It was a wider respect for borders that are made of relationships rather than lines. Explanations assembled like constellations, each a pattern drawn from a few bright points with darkness between them. One family of ideas began with draping. An interstellar magnetic field, slow and persistent, bends around the sun's inflated bubble and stretches into smooth arcs along the boundary. In that picture, the field that the spacecraft senses outside naturally runs almost parallel to the spiral carried by the solar wind near the nose. A dramatic rotation is not required, where the draped fabric lies nearly tangent to the surface. The magnetic tension of this fabric helps the boundary hold its line against the outward push of the solar wind, much as a taut sail keeps its shape in a steady breeze. If that fabric sometimes wrinkles into small folds, a gentle wandering of direction follows without overthrowing the overall alignment. A neighboring idea invokes reconnection as the sculptor of doors, where magnetic fields from the sun and from the galaxy meet with opposing orientations. Lines can break and join, trading partners in a choreography that releases energy and creates portals. Through those portals, particles migrate more easily than simple diffusion would allow. The porous frontier that the data imply fits this physics. In some stretches, reconnecting patches could link the two domains so intimately that solar particles leak outward and galactic ones pour inward along temporary corridors. In other stretches, topologies misalign and the frontier tightens, forcing travelers to scatter rather than stream. The irregular kinks in field direction and the episodic revival of certain particle populations become signatures of such opening and closing gates. The shape of the sun's domain welcomed a trio of competing portraits. One is a classic windsock with a single trailing tail, stretched by the motion of the sun through the local gas. Another is a bubble that ends not in a long wake but in a squat back, shaped primarily by magnetic pressure rather than flow. The third is a croissant, with two long lobes at high latitudes, formed when the sun's own magnetic field channels energetic particles into polar outflows that inflate twin appendages while the equatorial region stays more compact. Each geometry leaves a different fingerprint in the way particle gradients change with latitude, and in the pattern of energetic neutral atoms created by charge exchange between ions and neutrals at the flanks. The calm density rise, the stubborn field alignment, and the uneven texture of small kinks admit more than one of these portraits, which keeps the debate lively and the modeling inventive. Charge exchange stands as a quiet but powerful engine behind many subtleties. When a fast ion from the solar wind steals an electron from a slow, neutral atom drifting in from interstellar space, the roles swap. The former ion becomes a neutral that can travel in straight lines, and the former neutral becomes an ion that joins the plasma flow. This exchange cools, slows, and mass loads the solar wind in the outer reaches, while also seeding the region with fresh ions, later accelerated into anomalous cosmic rays. Outside the boundary, the reverse process sprinkles fast neutrals into the interstellar medium and removes momentum from the plasma at the skin of the heliosphere. In aggregate, these trades thicken the sheath and broaden the transition, supporting a frontier that is inherently layered rather than sharp. Some researchers sketch a stagnation region just beyond the nose. In that concept, the interstellar plasma approaching the sun's bubble slows and diverts, raising density and magnetic pressure before the flow turns to slip around the sides. A stagnation belt would explain a gradual rise in measured density and a quiet strengthening of field without a theatrical directional jump. It also meshes with the draping scenario, since lines that linger near the nose would naturally gather there, storing elastic energy like bent reeds, and then releasing it through small realignments that ripple outward. Cosmic ray transport called for its own set of refinements. Standard diffusion assumes particles move randomly through turbulent fields, but the measurements favor motion along extended arcs, punctuated by episodes of rapid streaming. One solution invites field line meandering, in which the lines themselves wander over long distances, carrying particles like beads on errant strings. Another introduces self-generated waves. As cosmic rays stream faster than the local Alfvén speed, they can excite resonant ripples in the magnetic field that in turn scatter the particles, throttling the stream and setting a natural ceiling on how fast it can flow. The resulting dance between particles and waves establishes a feedback that shapes gradients more gently than a simple barrier would. Temperature structure sparked kinetic interpretations. Instead of a single thermal bath, the distributions of electrons and ions resemble superpositions of cores and halos, with long tails containing a minority of faster particles. Such shapes occur where weak collisions and intermittent compressions allow micro-instabilities to bloom. Mirror and fire hose instabilities, driven by pressure anisotropies, can reorient energy between directions parallel and perpendicular to the magnetic field. If those instabilities erupt in the boundary's skin, they could explain subtle heating without a large-scale shock, and they could also roughen the effective permeability of the frontier to charged particles, reinforcing the idea of braided corridors that evolve in time. Neutral hydrogen gathered outside the bubble adds a luminous clue. Photons in the ultraviolet can scatter off that gas, revealing a brightened belt, sometimes called a wall, where atoms pile up against the sun's expanding influence. This crowding may be enhanced by charge exchange that slows atoms near the nose and by compression from the external field. If that ridge wraps the front of the heliosphere, it would contribute to the slow density increase sensed by radiotones, and it would firm up the notion that the boundary is more membrane than cliff. Speculation reaches farther into the neighborhood of stars. The sun drifts through a patchwork of interstellar clouds with slightly different densities, magnetic orientations, and ionization fractions. A transition into a new parcel would tilt the balance of pressures at the frontier, shifting the distance to the boundary and changing its character. If the local cloud contains filaments of enhanced field, the boundary might buckle as it crosses one, momentarily tightening or loosening the connection between domains. In that light, some slow trends in the measurements could be the signature of a larger journey through a textured medium rather than purely an expression of the solar cycle. Another speculative strand considers ancient shock fronts from distant supernovae. Even after their drivers have faded, such fronts can leave turbulence and field distortions that persist for long times. A relic ripple passing through the neighborhood could modulate the drape, alter the angle between external lines and the solar spiral, and influence the rate of reconnection. The rarity of loud interstellar radio storms along the path would remain intact, while the subtle undulations in density and direction find a natural external cause. The question of a bow feature in front of the heliosphere frames a careful distinction. A fast enough motion through a dense enough medium produces a true bow shock. If the sun moves more gently through a magnetized, less compressible gas, the result is a bow wave, a region of gradual compression without a discontinuous jump in properties. The latter sits comfortably beside the measured calm in temperature and the lack of strong radio bursts. A bow wave would also accentuate draping and assist the formation of a stagnation belt, guiding the flow to curve around the bubble in a manner that matches the quiet rise in density. Models that unite these elements tend to favor magnetohydrodynamics for the large scale and kinetic physics for the skin. On the big canvas, the heliosphere balances ram pressure, thermal pressure, and magnetic pressure in an asymmetric bubble. Along the skin, particles trade charge, fields reconnect, microinstabilities feed on anisotropies, and self-generated waves moderate streams. From this union emerges a boundary that is semi-permeable, regionally wrinkled, and temporally alive. The spacecraft crosses one chord of that shape, sampling a mixture of enduring structure and transient features. The agreement between measured densities and those predicted for the local interstellar plasma supports the basic framework, while the nearly aligned field direction preserves the demand for draping or lobal geometries. Practical implications flow from these theories. If magnetic pressure dominates, forecasting cosmic ray exposure for deep space travel must track the external field's orientation as diligently as the solar cycle. If reconnection opens intermittent doors, episodes of enhanced radiation could arrive even during otherwise quiet conditions, urging designs that expect pulses rather than only averages. If the heliosphere wears lobes, the protection at high latitudes may differ from that near the equatorial regions, subtly shaping the environment encountered by trajectories that leave the ecliptic. The final speculation is modest and resolute. The frontier is likely a generic feature of stellar systems moving through a magnetized galaxy. Variations in stellar wind strength, local density, and field orientation will write different dialects of the same language. The two robotic travelers have sampled the dialect near one small star. The grammar they reveal speaks of draped magnetism, traded charges, reconnection doors, meandering lines, and temperatures that remember. With such a grammar, the edge of a star's influence becomes understandable without being simplified away. The frontier remains a negotiation, but not a mystery without structure. It can be modeled, forecast, and slowly mastered, not as conquest but as comprehension. The tools that read the border are quiet machines and patient methods. Far from sunlight, a spacecraft keeps watch with instruments that sip power and speak in numbers that must be nursed across a vast radio hush. A long boom holds magnetometers away from the main body so that the spacecraft's own currents will not whisper lies into their coils. Wire antennas stretch outward like tuning forks, ready to feel the tremor of plasma waves as passing shocks stir electrons into chorus. Detectors count charged particles across many decades of energy, dividing the rain into species and stories, from the low-energy breath of a star to the hard messengers from distant remnants of explosions. Each sensor is a small citizen of a traveling laboratory, and each has learned to work with fewer watts than a nightlight. Communication is its own instrument. The Deep Space Network tilts vast dishes toward the dark and catches photons that have faded for the better part of a day. Receivers subtract noise with care, phase-lock to barely there carriers, and reconstruct bit streams that have crossed a tide of interplanetary static. On board, the craft schedules data like a librarian who knows the lights may dim at any hour. Priorities shuffle as power declines. A magnetometer sample may replace a lower-value spectrum. A plasma tone may be saved while a picture would go, though pictures now sleep. Compression algorithms squeeze long records into narrow windows, and housekeeping frames share space with science in a choreography that changes with the health of aging components. Testing the border requires clocks, so teams on Earth maintain calendars of solar eruptions and model the outward march of shocks through the heliosheath. When a shock is expected to pass the distant craft, analysts listen for the telltale ring at the electron plasma frequency. That ring yields density without touching the gas, a pure inference from pitch alone. Sequences of such tones, months apart, become a plot of density with distance. The plot does not need to be dramatic to be decisive. A slow rise, repeated often enough, becomes a contour line for a region that no eye can see. Other ears listen from nearer home. Space telescopes at Earth's orbit and probes inside the orbit of Mercury watch the sun's magnetic fields knit and unravel, track coronal mass ejections as they billow outward, and measure the wind before it has thinned. Solar wind monitors at the Earth-Sun Lagrange points provide the starting conditions for large-scale models. Those models are run on supercomputers that integrate the magneto-hydrodynamic equations outward across hundreds of astronomical units, incorporating charge exchange with neutral atoms and the pressure of energetic particles. The outputs are not just pictures, they are predictions of when and where the border will thicken, slacken, or briefly open corridors through reconnection. The spacecraft offers ground truth, and the code learns humility or confidence accordingly. Imaging the frontier from afar uses neutrals rather than light. Energetic neutral atom cameras convert exchanges between ions and atoms into maps. Where charge exchange is busy, more neutrals fly straight to the detectors, carrying directional information that photons cannot provide. Those maps have revealed ribbons, arcs, and regions of enhanced emission that hint at draped magnetic fields and pressure ridges outside the sun's bubble. They also give context to a single point crossing. When a distant instrument reports a plateau in particle counts, a neutral atom image can suggest whether the plateau lies along the flank of a lobe, the nose of a compressed shell, or a corridor threaded by connected field lines. A second messenger arrives from cosmic ray observatories closer to Earth. Long-term records of high-energy particles, captured by ground-based neutron monitors and by space-based spectrometers in orbit, preserve the modulation imposed by the heliosphere on the galaxy's weather. When the distant craft reports the shape of spectra beyond the boundary, those shapes become boundary conditions for models that reach back toward Earth. The agreement or disagreement between inner system monitors and outer system samplers allows the entire shield to be characterized as a function of time and solar cycle. Space weather is not only a story of storms near the Sunday, it is also a story of the long negotiation at the edge that sets how much the inner worlds must endure. Maintenance is a scientific act when the laboratory is a star's length away. Attitude control thrusters respond to commands that rotate the high-gain antenna toward Earth by fractions of a degree, preserving a link that a whisper could break. Heaters toggle according to schedules that balance instrument survival against the need to save power for another winter in the cold. Memory patches change the way a subsystem reports its state or choose a new table for compression ratios. Each intervention is a test, a small experiment with one subject, designed not only to keep an instrument alive, but to understand how its aging might bias what it says about the sky. Data analysis becomes a tool as definitive as copper and silicon. Change point detection algorithms hunt for shifts hidden in noisy sequences, the moments when gradients alter their slope or when a rare event marks a reconnection burst. Bayesian methods weigh competing explanations for a subtle kink in field direction, assigning probabilities rather than verdicts. Machine learning helps classify particle anisotropies into families that may correspond to different topologies of field connection. The goal is not to replace physics with pattern recognition. It is to let statistics point to where physics should look more closely, to which minutes in a long year deserve human attention. Laboratories on Earth reproduce small pieces of the border's physics in miniature. Plasma chambers with controlled magnetic fields examine reconnection at scales that instruments can resolve. Beams of ions pass through neutral gas to measure cross-sections for charge exchange at energies that match those in the distant sheath. Turbulence is not conjectured but generated, diagnosed with probes that can step through space faster than a spacecraft ever will. The results feed the coefficients in models, anchoring free parameters to data rather than taste. New observatories prepare to replace aging eyes. Neutral atom imagers with higher sensitivity and sharper energy resolution are designed to watch the heliosphere's skin breathe, with the solar cycle and with the patchwork of the local interstellar medium. Particle instruments aboard distant planetary probes continue to log the spectrum of the outer solar wind, providing context for the far edge. Radio receivers at the longest wavelengths wait for radio quiet above the ionosphere, perhaps on the far side of the Moon one day, so that the lowest kilohertz bands can be explored without terrestrial interference. Such listening would complement the plasma wave tones, offering a map of where the interstellar medium itself occasionally cracks into radio voice. An interstellar probe has graduated from dream to studied concept. The plan imagines a fast departure, a gravity assist at a giant planet, and a direct march outward to several hundred astronomical units within a human lifetime. The payload would include a plasma instrument that never fell silent, a magnetometer with broader dynamic range, and neutral atom imagers that could survey the skin of the heliosphere from the outside looking in. A dust analyzer would weigh the sieve, measuring grain charges and sizes in the region where galactic grains become new migrants to a planetary system. The purpose is not to repeat a crossing, but to read the frontier as a global weather system and to view the home bubble as one object among many in a galactic archipelago. Testing continues at every scale. Near the Sun, probes dive through the inner wind to discover how turbulence is born. In the middle heliosphere, cruisers measure how that turbulence matures and how charge exchange slowly loads the flow with neutrals from outside. At the border, the travelers hear density by pitch and direction by slow drift. Outside, the skin answers with a restraint that still permits motion. The combined arc from center to edge becomes a single instrument, one long ruler made of many smaller rulers, each calibrated against its neighbors until the uncertainty narrows into confidence. There is also a measurement that no device owns. Time itself weighs the frontier. As the star's cycle alternates between busy and quiet, as the local interstellar medium reveals filaments and calm bays, as neutral atom maps shift their glow and cosmic ray monitors record their subtle seasons, the story accumulates. Long baselines turn hand-waving into contour lines. A patient century of listening would make a map no single mission could hope to draw. Plans for such longevity already thread through the design of instruments and the placement of observatories, acknowledging that some negotiations in space require the patience of generations. The edge reveals itself to those who ask simple questions with durable tools. What is the density? Which way does the field point? How many particles of each energy arrive from which directions? When do tones ring and when do they fade? Each question has a sensor, a model, a cross-check, and a path toward better versions. The ongoing test is not to reach farther only, but to hear more finely. The border will continue to fold and smooth as the star breathes and the galaxy presses. The instruments will continue to translate that motion into a language of counts, pitches, and vectors. From that language, certainty grows, not sudden, but steady, like dawn on an ocean that has no shore. Ultraviolet light revealed a ridge before any particle counter did. Hydrogen, the most common atom in the galaxy, scatters a narrow blue-white photon called Lyman alpha with exquisite sensitivity. When sunlight floods outward, some of that light bounces off interstellar hydrogen that has drifted near, and some is absorbed along sightlines to nearby stars. The measurements form a whispering map. Along that map, a band appears brighter and thicker than the rest, a sign that atoms have piled up against the sun's expanding breath. The ridge is not a wall in the solid sense. It is a raised bank, a region where neutral hydrogen grows denser because the solar wind slows and magnetic pressure from outside presses back. Space there is not empty. It glows in a line so sharp that celestial mechanics turns into cartography. The journey of an atom to that ridge begins far away. Interstellar hydrogen molecules break into atoms in diffuse clouds and wander into the neighborhood with the galaxy's slow drift. Most arrive neutral, unaffected by magnetic fields, and pass straight until a close encounter changes their role. In the outer reaches, ions from the solar wind steal electrons from these neutrals through charge exchange. The swap creates a fast neutral that can keep going unhindered and a slow ion that joins the plasma. The trade cools and loads the wind, but it also leaves behind more slow hydrogen near the nose of the heliosphere than would otherwise be there. Add the gentle compression from the draped interstellar magnetic field, and a crest forms. Ultraviolet detectors register this crest as extra scattering and extra absorption against hot stars. It is the simplest kind of signal, a brightening that says matter has gathered. Radiation pressure complicates the pile. At Lyman alpha, sunlight pushes on hydrogen enough to rival gravity. During times of high solar activity, the pressure increases, and neutral atoms feel a stronger outward shove. Their trajectories bend before they approach the sun, carving a hollow that changes with the cycle. Some atoms are deflected into the ridge region, thickening it, while others are pushed aside. In quiet years, radiation pressure relaxes, and more hydrogen slides inward before exchanging charge and joining the plasma. The ridge breathes with these seasons, brightening and softening in patterns that ultraviolet observers can track with patience. The breathing is delayed by distance, so the ridge becomes a clock that lags the sun's pulse. Heavier cousins help diagnose the flow. Neutral helium moves through the solar system with less fuss because radiation pressure at helium's lines is weak and ionization rates differ. Detectors that count incoming neutrals find a focused cone of helium downstream of the sun's motion, shaped by simple gravity. Hydrogen refuses such neatness. Its cone is smeared and shifted by radiation pressure and by the charge exchange that seeds the ridge. The plane that best describes the deflection of hydrogen from helium defines a reference for the local magnetic field's orientation. That deflection plane becomes a forensic tool. It encodes how the external field tilts, and therefore how the ridge wraps the front of the heliosphere. Geometry hides in the way two elements disagree. Spectra trace the ridge with the precision of a violin string. When light from a nearby star passes through the interstellar gas around the heliosphere, the Lyman alpha line appears with extra absorption on one side. The shift and depth of that added bite reveal the speed and density of piled-up atoms. Observers separate the contributions from the general local cloud and from the ridge itself by their small velocity difference. The result is a clean detection of matter that has been slowed and compressed near the sun's frontier. Similar techniques applied to other stars reveal comparable ridges around them, a quiet census of astrospheres in the neighborhood. Each ridge carries information about a star's wind strength and the pressure of the medium it sails through. The sun's ridge is simply the one near enough to study in fine relief. Energetic neutral atom imaging draws another contour of the same feature. Where ions exchange with neutrals near the boundary, fast neutrals fly straight toward detectors closer to home. The distribution of their energies and directions sketches bright arcs that trace regions of enhanced interaction. The ridge participates in that glow by feeding the exchange with its extra atoms. Maps show bands that wrap across the sky at angles that match expectations for a draped external field. These bands sit alongside the ultraviolet brightening, and together they suggest a layered skin where compression, exchange, and magnetic tension share the job of sculpting the frontier. Dust adds texture to the ridge's influence. Charged grains feel the curved paths imposed by fields and the filtering of the heliosphere's electric environment. The ridge, by virtue of increased density and altered ionization balance, changes the trajectories of certain grain sizes. Instruments that hear the tiny clicks of dust strikes record subtle changes in rate and grain character as the spacecraft moves outward. The sieve that the heliosphere represents for dust therefore begins to show its mesh near the ridge. What kinds of grains can pass into the planetary system, and how many, depend in part on this accumulation of atoms just beyond the sun's wind. Temperature in the ridge carries memory. Charge exchange does more than move atoms and ions. It transfers energy between them. A hot ion that becomes a neutral departs with a hot velocity distribution. A cold neutral that becomes an ion enters the plasma with a cold one. The mixture near the ridge contains both sets of histories. Ultraviolet line shapes broaden slightly beyond what pure thermal motion would predict, signaling the superposition of populations that have not yet fully blended. The persistence of these non-thermal tails constrains how quickly collisions and waves redistribute energy at the frontier, a delicate balance in so thin a gas. Interpretations of the ridge reach toward the question of a bow feature. If the sun's motion through the local medium is modest and the magnetic field stiff, the compression ahead will spread over many tens of astronomical units, and form a bow wave rather than a sharp shock. The ridge then becomes the densest part of that wave. Its brightness and breadth align with such a gentle structure. A true shock would heat hydrogen more strongly and produce line signatures that have not been seen in strength. The ridge's calm supports the bow wave view, a picture of space weathering that favors pressure and draping over brute speed. The ridge also sharpens the outline of the heliosphere's nose. A stronger external field or denser local gas would drive the ridge closer in. A weaker combination would let it sit farther away. Observed distances and densities therefore fix the scale of the entire bubble with better confidence. This calibration feeds back into models that forecast how deeply galactic cosmic rays can penetrate before the heliosphere turns them aside. A thicker ridge means more charge exchange, more mass loading, and a softer outer wind that offers a different kind of shield than a thinner ridge would. Shielding, in this sense, is not a single curtain. It is a set of layered veils, and the hydrogen wall is one of the first veils that incoming particles meet. A modest chemical clue hides in deuterium, the heavier isotope of hydrogen. Its Lyman alpha line sits slightly to one side of the main hydrogen line. Careful spectra can separate the two. Ratios of hydrogen to deuterium within and near the ridge hint at how charge, exchange, and filtration discriminate among speeds, subtly altering abundances that drift inward. The variations are not dramatic, yet they reveal that the ridge is not just a pileup, but also a selective doorway. What passes through does so with biases written in mass and cross-section. The Sun is not alone in wearing such a feature. Observations of other stars show excess absorption in Lyman alpha that can only be explained by material piled up outside their wind bubbles. Those astrospheric ridges vary in strength. Hot, fast winds carve clearer cavities and can crowd more gas at the nose. Cool stars with weaker winds leave thinner signatures. By placing the Sun among these relatives, the ridge takes on another role. It becomes a comparative yardstick that situates one bubble within a population and turns a local measurement into a small piece of galactic climatology. Uncertainties keep the ridge interesting. Radiation pressure varies with the Sun's ultraviolet output, which itself changes on multiple timescales. Ionization rates drift with both solar conditions and with the local medium's subtle shifts. The transport of fast neutrals from the ridge to detectors closer in must be corrected for losses along the way. Each correction stretches a thread that needs checking. Redundancy helps. Ultraviolet scattering and stellar absorption run on separate systematics, as do neutral atom maps and dust clicks. Where their answers agree, confidence grows that the ridge has been drawn truly. Where they diverge, new physics may be hiding in what looked like calibration. The ridge's existence carries a quiet philosophical weight. A star cannot reach into the galaxy indefinitely. Its breath finds a counterpressure and builds an interface that remembers both actors. The hydrogen wall is that memory made visible. It is written in a color that human eyes cannot see, yet it is as real as any coastline. It says that even in a place with almost no matter, boundaries arise from the faintest of interactions and persist long enough to be mapped. The ridge is not a fortification. It is a sign that two domains have met and negotiated a shared shape. A spacecraft that glides through the neighborhood need not touch the atoms to know they gather. Light, counted patiently, tells the tale. Two paths into the same sea rarely feel identical. A second craft, moving below the Sun's equatorial plane, entered the frontier with instruments that still tasted the plasma directly. Its trajectory threaded latitudes the first had never owned, and its clock met a different phase of the star's temper. Confirmation arrived as a sequence of familiar signs, yet each wore a new accent. Contradiction arrived as gradients that rose and fell on different slopes, as though the border owned regional weather and a traveler's direction determined which clouds and calms would greet it. The first measure to sharpen was the speed and temperature of the plasma itself. A working analyzer counted ions and electrons and placed them on a scale. The flow slowed to a crawl relative to the craft, cooler than the heated sheath within, and denser than the solar wind by the expected factor for interstellar gas near the nose of a stellar bubble. Density did not jump like a cliff. It stepped and held, then stepped again, an orderly but layered ascent that suggested the craft was sliding through a skin with structure. The values corroborated numbers that had once been inferred from radio tones alone, fixing them with direct taste instead of echo. Confirmation could hardly be cleaner than a thermometer and a speedometer reading the same calm. The counters that listen for high-energy messengers agreed on the larger tale. Galactic cosmic rays settled into a higher, steadier abundance outside than within. Their directional preferences softened with distance, and the overall gradient with radius relaxed. Yet the exact cadence of the rise differed. In the south, the climb toward the outer plateau unfolded over a shorter span, with smaller pauses, as if the route through the skin included fewer twists. That difference carried consequence. A shorter transition argued for less tangled connectivity near that latitude, or for a quieter recent history of reconnection patches. The border that had seemed long and braided above the plain appeared tighter and better ordered below it. Low-energy solar particles folded their tents in both crossings, but the retreat left a different silhouette. The southern path saw deeper dropouts with fewer recoveries. That pattern hinted at a boundary more decisively sealed against inward recirculation of solar wind debris, at least during those months. The sun's cycle likely played a hand. Magnetic conditions nearer the star had eased toward a quieter season, reducing the supply of disturbances that could pry open temporary lanes. Geometry played its hand as well. If field lines outside draped in a way that curved away from southern longitudes, inward streaming would be less favored there. The data could not choose one reason and reject the other. Instead, they sketched a portrait where timing and latitude cooperated to enforce a stricter border. Magnetism preserved a puzzle while altering its frame. Field strength on the outside rose to a familiar half-nanotesla neighborhood, steady and confident. Direction, once again, refused a dramatic swing. It drifted and kinked in modest ways, echoing the idea of draped alignment that does not require a theatrical pivot at the nose. But in the south, brief rotations appeared with a touch more courage. Small excursions traced arcs that looked like the edges of reconnection islands turning past the boom. Those arcs did not persist long, and they did not add to a grand rotation. They did, however, mark a livelier fabric at small scales, a hint that the southern skin was quilting and requilting itself with patches that came and went more frequently than in the north. Energetic neutral atom maps, taken from nearer home, gave the second route a different backdrop. Bright ribbons and arcs that hang across the sky in those images appeared shifted in a way that made the southern crossing pass beneath a region of modest emission rather than through a ridge. That context aligned with the observed brevity of the transition. Where exchange is less busy, fewer fresh ions are born to thicken the sheath, and the path from solar wind to interstellar plasma can shrink. The second craft's reports nodded toward that interpretation without insisting on it. Both sets of instruments were far from the images that saw the glow, and the inference required care. Anomalous cosmic rays, those ions born from interstellar atoms that wander in, offered a forceful contrast. Their decline outside the border, seen before, repeated in the south but with quicker resolve. Small revivals appeared less frequently. The acceleration factory near the termination shock seemed more isolated from the southern flank of the interstellar medium during that period. Again, both geometry and timing could explain the cleanliness. If the outer field lines leaned such that fewer doors aligned, or if the star's recent storms had been fewer, there would be less opportunity for samples of this species to leak outward and be counted by a traveler who had already left the factory's grounds. Dust strikes told a quieter version of difference. Click rates and charge signatures changed subtly with distance in a manner consistent with the filtering of certain grain sizes by the heliosphere's magnetized sheath. In the southern records, the change showed a slightly sharper knee, as if the sieve threads were pulled tighter. If the outer field pressed more strongly on that side, or if the local distribution of grains approached along a different angle, the mesh could feel finer. Such subtleties, barely above noise and carefully extracted, lent weight to the idea that the border's character varies around its curve. The termination shock had been encountered by both craft earlier in their journeys, yet their distances at that encounter differed by several astronomical units. The southern traveler had met the shock closer to the Sunday, That earlier sign already warned of asymmetry. The later crossing of the final boundary continued the theme. The heliopore's distance differed by a couple of astronomical units between the two, and the ordering relative to the shock did not simply mirror. External field pressure, solar cycle phase, and latitude apparently teamed to shift the entire architecture subtly inward in the south. A bubble pressed by an oblique hand will not shrink evenly. Temperature structure in the electron population preserved a shared story of cores and halos, but the balance between them leaned differently. The southern data favored a slightly cooler core with a more modest halo. Such a distribution would be natural if fewer recent compressions had stirred the plasma outside, or if wave activity that redistributes energy across pitch angles had been weaker along that segment. The conduction of heat and the scattering of cosmic rays both care about those tails. Small differences in their shape translate into different mean-free paths and therefore different regional permeability for charged travelers. Plasma wavetones continued to act as a ruler. The southern tones rang at frequencies that stepped upward across a handful of events with shorter spacing. Conversion to density yielded a slope that agreed with direct measurements and carved the rise into a slightly steeper hill. When matched against catalogued solar eruptions, the delays drew lines that traced through the sheath with fewer detours. The medium outside answered like a spring under firmer tension, transmitting ripples with less dispersion. That behavior fit the image of a less tangled drape and a cleaner flow deflection in the southern quadrant. Even the spacecraft's own constraints played into the contrasts. Power budgets forced different duty cycles and integration times. The southern plasma instrument, alive and hungry, commanded bits that the northern version had surrendered to silence. Spectra were richer in low-energy detail, and some fast variations were caught that would have slipped through broader averages. What looked like a brisker transition may partly reflect sharper sampling. Engineers and analysts accounted for this possibility. Yet in any comparison between two biographies, the style of listening matters alongside the song itself. The combined picture did not collapse into a single textbook diagram. It organized itself into a map with regional norms. Near one latitude, the heliosheath swelled, particle gradients meandered, and reconnection signatures came as occasional pinpricks. Near another latitude, the sheath thinned, particle gradients steepened, and small rotations visited more often. Both sectors belonged to the same object, a pressure-balanced bubble held in shape by outward wind, charge exchange, and external magnetic insistence. The second path did not negate the first. It filled the outline and shaded the relief. Implications reach beyond a tidy catalogue of differences. Shielding against galactic radiation is not a uniform curtain. A route that exits near southern longitudes may experience a swifter exposure to the ambient cosmic ray climate than one that lingers in a thicker sheath. Forecasts for deep space mission risk acquire a dependence on latitude and epoch that cannot be ignored. The sequencing of solar activity matters twice, first for how it prepares the sheath upstream, and again for how it stirs the outer membrane into temporary connections or leaves it sealed. The greatest contradiction was philosophical and useful. Expectation had long favoured a single, somewhat universal signature of crossing. The second craft taught that a frontier this broad can honour the same physics while expressing it through multiple local grammars. Confirmation and contradiction are not opponents in such work. They are collaborators that refine truth until it can tolerate variety. A boundary can be one thing in law and many things in habit. Two passages taught this more deeply than one could ever have done. The southern traveller continues outward with its set of senses, sending numbers that refine contour lines into something closer to texture. The differences it chronicled are not noise. They are the face of a living border with seams, belts, and eddies that depend on where it is touched. The likeness to a sea grows stronger under such study. One current accelerates through a narrow, another curls along a bank, and the same chart that guides both must show both. A star's edge turns out to be a geography, not a gate. The rain beyond the bubble is not water. It is a flux of charged shards, born in shocks that once raced from exploded stars, steered by magnetism older than any calendar, and hardened by distances that laugh at scales familiar to planets. A small machine counted that rain with paddles and crystals that flash when a high-energy particle slices through. The count rose when the craft passed into the wider medium, then steadied at a level that could not exist inside the sun's soft shelter. The difference was not a rumor, it was arithmetic. The galaxy was not quiet, it was simply far. Each messenger carried a signature. Protons, the most common, arrived with energies that spanned from a few 100 million electron volts into realms many orders of magnitude higher. Helium followed with a smaller chorus and a heavier step. Traces of carbon, oxygen, iron, and rarer nuclei joined the traffic, each nucleus a fragment of a story written in supernova shock fronts, in the tangled folds of superbubbles, and in the slow leavening of interstellar gas by ancient stellar deaths. When the spacecraft tasted this mixture outside, the spectrum grew cleaner. Inside the sun's domain, the lower energies had been thinned by the wind's magnetic weave. Outside, the low end filled in, revealing the galaxy's preference for a slope that bends gently with energy, rather than breaking abruptly at the threshold set by the heliosphere's shield. Direction added nuance. A rain that fell equally from all sides would be simple to describe and easy to model. The detectors saw something slightly less naive. Anisotropies, small and slow, marked preferences that drifted with time, as if the particles walked longer along some magnetic corridors than others. These preferences softened with distance from the frontier, suggesting that the immediate geometry of the drape and the arrangement of reconnection lanes gave way to the broader tapestry of the interstellar field once the craft moved farther into the open. The transition from local choreography to galactic average could be watched directly in the way directional differences faded like footprints in a steady surf. The spectrum itself became a map. Plotting intensity against energy showed a smooth rise toward lower energies outside the bubble, but that rise did not continue forever. At very low energies, even the galaxy suppresses its own whispers, not by intent, but by the thickening of self-generated waves. As cosmic rays stream, they jostle the magnetic field into ripples that scatter the next wave of travelers, a feedback that sets a ceiling on how quickly particles can drain along a particular line. The measurements recorded the consequence, a flattening at the lowest accessible energies, as if the medium itself demanded patience. This shape, joined to the higher energy fall that belongs to the galaxy's reservoirs and accelerators, formed a curve that modelers had long drawn. Now it existed in numbers taken from the dark. On some days the rain dimmed briefly. Shocks launched at the sun long before, travelling outward through the thinning wind, arrived at the boundary and pushed a temporary hush into the ambient cosmic ray population. These decreases resembled the Forbush events known closer to home, but their character outside differed. The amplitude was smaller, the recovery slower. The frontier filtered the disturbance, allowing only a measured echo to pass into interstellar space. The echo was still clear enough to time the march of distant shocks and to weigh the permeability of the skin. A boundary that seals completely would let no hush outside. A boundary that admits everything would erase the difference between inside and out. The data spoke for the middle, a semi-permeable membrane that damps, delays, and edits. Electrical charge matters in a rain of charged particles. Drifts that depend on the sign of charge steer protons and heavier positive ions differently from electrons and rare negative fragments. Across a solar magnetic cycle, the large-scale polarity of the sun's field flips. That flip changes how particles prefer to slide along gradients and curvature near the heliospheric border. The counts recorded beyond the bubble carried a faint memory of this choreography. Subtle differences in how anisotropies evolved across years betrayed the underlying drifts, even in a region that should be ruled by the galaxy's field. The lesson was not that the sun dominates far away. It was that transport is a compound act, with charge sign, energy, and field geometry playing intertwined roles even where the local actor has grown small. Composition offered clues to origin and history. Ratios of helium to protons, of carbon to oxygen, and of heavier nuclei to the lighter host recorded how sources and transport cooperate. A higher fraction of heavier species at certain energies echoed the energy-dependent escape from supernova remnants and the spallation of nuclei as they strike interstellar atoms during their long passage. Outside the bubble, the ratios matched expectations from models that had been tuned to near-Earth measurements corrected for the shield's modulation. The match confirmed that the local piece of the galaxy, sampled by the craft, shares kinship with the cosmic ray population inferred nearer home. A stellar neighborhood, it seemed, tells the same compositional story when the sun's filter is lifted. Radiation is not an abstract for travelers. The counts translate into dose, and dose into risk for electronics and for living tissue. Beyond the bubble, the integral of flux at many energies rose to levels that matter for long voyages. The thin shelter afforded by a spacecraft's hull can only soften a spectrum that spans so broadly. The measurements allowed forecasts to be rewritten with less guesswork. Shielding design could now adopt the actual shape of the low-energy tail that matters most for deposited energy, not a shape extrapolated across a border. Instruments aboard the aging craft did not measure damage to their own bodies as a dosimeter would, but their memory errors and bit flips offered a soft mirror of conditions that human missions would face on scales of years. The modulation that the heliosphere provides became quantifiable rather than qualitative. By comparing spectra, inside and outside, a potential could be inferred, a single parameter that approximates the shielding effect on the lower energies. This potential is not a true voltage, but a bookkeeping device that gathers the influence of drifts, diffusion, convection, and adiabatic cooling into one number. Its value, tracked across time, matched the breathing of the sun's cycle and tied to records from neutron monitors on Earth that had watched cosmic rays wax and wane for decades. The boundary thus linked the oldest time series of space weather to a clean sample of the source environment beyond. Transport coefficients, once guessed at, found new anchors. The effective diffusion experienced by charged particles outside the bubble is set by turbulence in the interstellar field. The slope of the gradient with distance, joined to the pace at which small anisotropies relax, implied a diffusion that is neither so weak that particles trickle, nor so strong that structure vanishes in a moment. Models that made field lines wander over long arcs reproduced the slow flattening of gradients. Models that kept lines too rigid failed. Self-generated waves at the lowest energies had to be included to keep the spectrum honest. With such tuning, simulations could carry a particle born in a blast wave tens of millions of years ago to the detectors on a machine running on the heat of decaying atoms. The rain held signatures of memory longer than any human plan. The time required for a typical galactic cosmic ray to approach the solar neighborhood from its accelerators is measured in millions of years. The sources that fed the current spectrum may include remnants long cooled, associations of massive stars whose winds once carved superbubbles but now sit quietly in the arm of the galaxy, and shock fronts that crossed the local medium before the first radio dish ever tracked a distant whisper. The spacecraft's numbers made that ancientness palpable. They showed a present that is a chorus of histories, each folded into the smoothness of a spectrum that hides the names of particular sources and preserves the physics of many instead. Implications reach inward. Planetary atmospheres carry scars written by cosmic rays. Ionization at high altitudes seeds chemistry that shapes ozone and other species. Ice records on worlds with seasonal snows hold faint stratigraphies influenced by radiation that has been modulated by the sun's long moods. Electronic systems age under the quiet rain in ways that matter for satellites and for habitats imagined beyond Earth. The frontier defines how much of the galaxy's weather reaches those arenas. Measurements outside complete the circuit. They grant a baseline against which to measure the sun's gift of moderation. There is a quiet beauty in using stones of the universe to see the shape of an unseen shore. Each high-energy particle that entered the detector was a tracer that had drifted through fields that no eye could paint. Together they drew a relief map of a shield and its opening. They traced how a star's breath edits the galaxy's manuscript, softening some lines, leaving the strongest strokes intact. Outside, the manuscript is fuller. Inside, it is redacted by kindness. A small machine made the redactions legible. Not every question found an easy seat. How exactly the lowest energy tail bends in the presence of self-generated waves remains a study in evolving detail. Whether nearby hot bubbles or relic ripples from ancient supernovae lend a local flavor to the diffusion outside is still a debate that will welcome a second clean chord farther out. But uncertainty does not smother clarity. The clarity is that the galaxy reigns on every system, that stars build umbrellas of magnetized wind, and that the size and texture of those umbrellas can be measured. A border is a filter. The rain beyond it is the true climate. Magnetism at the frontier behaved like a patient riddle. Field strength rose in a firm step, yet direction did not leap to a new compass. The boom listened to a line that seemed familiar, then watched it drift by slow degrees as if the sky preferred continuity over spectacle. This reluctance to swing spawned a suite of interpretations that shared one trait. None could claim victory without leaving traces that instruments might one day catch. The riddle endured because each trace arrived faint, partial, or braided into others. A simple picture would have granted a tidy turn where the sun's spiral yields to the galaxy's thread. The spiral is born from rotation and wind, a graceful corkscrew that fills the solar cavity. The thread outside owes allegiance to currents wound on scales far beyond a single star. Where such fabrics meet, intuition calls for a seam that points in a different direction. Instead, the needle slid along nearly the same bearing. The remedy many favored was magnetic draping. A steady external field, pressed against a rounded obstacle, bends and lies along the surface, making the outer lines nearly tangent near the nose. A craft, crossing close to that nose, would follow a direction change so gentle that the compass hardly notices. If the crossing is slightly offset, a small arc appears, not a swing. The data matched that quiet arc more often than not, yet draping alone could not explain every twitch. On some days, the field kinked with abruptness that hinted at reconnection, the process that breaks and rejoins lines when opposed fields touch. A reconnection exhaust leaves hallmarks. A narrow jet, a brief rotation, a spike or dip in field strength, and altered flows of particles aligned with the new channel. Several episodes resembled such signatures, as if the frontier were quilting itself with islands of newly joined fabric. The sizes inferred from the duration of these events suggested structures spanning fractions of an astronomical unit to several, too small to be global, too large to be dismissed as noise. The frontier, it seemed, harbored pockets where lines crossed and traded partners, opening short-lived doors that later stitched shut. Another strand of the puzzle lay in heritage. The solar wind carries a sector pattern, slices of opposite magnetic polarity, divided by a vast current sheet that wobbles as the sun's tilted field rotates. In the outer reaches, that sectoring can be compressed into a stack of thin layers. Some of those layers survive the termination shock, carried into the sheath as folded pages. If an explorer meets the heliopause at a place where these sectors crowd the skin, the local field may flip direction over small distances without announcing a new outside orientation. The compass would record hops around the old solar imprint, while the external drape remains largely parallel. A few abrupt flips bore the right cadence to be such surviving sectors, thinned to filaments by distance and time. Pressure anisotropy added a quieter twist. In magnetized plasmas, particles can carry different pressures along and across the field. If perpendicular pressure grows too large, mirror instability seeds, ripples that trap and bounce particles, modulating field strength without sweeping direction. If parallel pressure dominates, fire hose instability can loosen tension and let lines sway. Both effects can live in the boundary, fed by pickup ions from charge exchange and by the steady compression that the drape imposes. Their footprints are subtle, a fine-grained waviness, a preference in particle pitch angles, and a slight broadening of wave spectra. The riddle's persistence owed something to these microturbulent stitches, blurring what would otherwise be a clean curve. Turbulence itself played a broad, indispensable role. The heliosheath is not an ordered laminar flow. It crackles with eddies and a spectrum of fluctuations that cascade from large scales to small. Outside, the interstellar field is not perfectly smooth either, but its turbulence differs in flavor and amplitude. Where the two meet, their spectra must negotiate. Instruments recorded wave power that slid from one regime to the other across the skin. with no single break that could be called a boundary. In such a blend, direction can wander under the influence of multi-scale ripples, and the time-averaged bearing can remain steady even as instant values twitch. The riddle matured into statistics, mean direction aligned, variance alive. Cosmic rays, by their own passage, wrote notes into the field. Streaming faster than the local Alphen speed, they excite resonant waves that in turn scatter the next wave of travelers. This feedback alters the local turbulence and can nudge the field's small-scale texture. The effect is strongest at low energies, where the phase speed of waves matches particle motion more easily. In the records, the smallest bends and the softest boosts in wave power sometimes coincided with changes in the low-energy tail of the cosmic ray spectrum. The frontier could not be treated as a passive membrane. The messengers that crossed it also tuned its strings. Geometry insisted on asymmetry. The sun's motion through the local gas tilts the nose, while the external field arrives with an angle set by faraway currents and nearby clouds. If those directions skew, the drape will gather more tightly along one flank, and reconnection will find more favorable alignments along another. Measurements along two latitudes already pointed to a thinner skin southward and a more braided complexion northward. The magnetic riddle then became a cartographic one, where along the nose do drape, sector shell, reconnection patches, and micro-instabilities take turns in shaping the local manifesto. A single crossing writes a single stanza. The full poem waits for multiple lines. Dust and neutrals added silent pressure to the script. Charge exchange near the skin injects pickup ions, whose gyrations carry a ring distribution. Such rings are fertile seeds for waves that ripple along the field and perturb direction in small, lasting ways. Neutral atoms that become ions outside join the external flow with speeds that imprint their old trajectories. This admixture builds anisotropies that must relax, and the relaxation rides on the very waves that shape the field. Nothing at the border is chemically pure, and every impurity adds a line to the magnetic ledger. Wave catalogues grew useful as dictionaries. Broadband fluctuations suggested a cascade that remembers its parents in the sheath. Narrowband tones marked times when shocks from the sun passed and rang the external medium. In between, a hum persisted at levels that carried information about compressibility and stiffness. Comparing those catalogues with the compass record clarified which wobbles belong to waves riding on the field and which belong to the field's own slow reorientation. The difference matters. A wave can be averaged away to reveal a mean. A reorientation becomes the mean. Some models proposed flux ropes at the skin, twisted bundles of field that peel off through reconnection and drift away like smoke rings. A crossing through such a rope would imprint a smooth rotation in direction over minutes or hours, accompanied by a bulge in field strength. A few events fit that silhouette, others fell short. The ropes, if present, may be numerous and small, turning the skin into a froth where individual signatures blur into a texture. That texture would produce the observed gentle variance without declaring any single monumental turn. There remained the accounting of magnetic pressure. Outside values stood near half a nanotesla, enough to match or exceed the ram pressure of the local flow near the nose. Where magnetic pressure rules, the boundary obeys elasticity more than inertia. Push gently and it bends, push harder and it stiffens. The compass thus reads a field that resists sudden change. The stronger the external field, the more likely draping will dominate the geometry, and the less likely a dramatic rotation will appear along any short chord. The riddle's central clause could then be recast. Not why did the field refuse to turn, but why did anyone expect it to turn sharply under a regime governed by tension? Measurement limits influenced confidence. The magnetometer's cadence and resolution are finite, and the slow roll of the spacecraft sometimes folds geometry into the signal. Calibration lines must remove the craft's own whisper without shaving fine truth. Analysts tested for hidden rotations by comparing particle pitch angle distributions that would realign if the field truly swung. Often, pitch angles stayed loyal to the magnetometer's report. At other times, small mismatches warned that an unresolved twist might hide in the blend of waves and rotation. The riddle kept a fraction of its letters smudged by the mechanics of listening from a single moving point. A broader view suggested truce rather than verdict. Draping sets the baseline direction. Surviving sector pages, compressed into thin layers, add quiet flips superimposed on that baseline. Reconnection patches open gates and draw brief arcs that slightly jog the bearing. Micro-instabilities and pickup-driven waves lay a fine ripple on top. Turbulence from both sides blends the whole. What emerges at the boom is a field that is stronger than before, nearly aligned with the old course, sprinkled with small kinks, and unwilling to announce a clean break. The puzzle persists because nature seldom spends all her budget on a single effect. The frontier is funded by many. Clarity grows anyway. Each new interval of calm adds confidence to the aligned baseline. Each brief kink traces the statistics of reconnection. Each long, gentle drift kneads the drape into a measurable arc. With time, the magnetic riddle becomes less a question of what and more a ledger of how much. How much of the variance belongs to sector fossils? How much to reconnection? How much to waves fed by pickup ions and cosmic rays? The compass will keep answering in patient decimals, and the answers will keep drawing a boundary that is less a line and more a gathered field, stretched, stitched, and sung into shape by the softest forces in a hard vacuum. Shapes presented themselves like masks held up to a lantern. Each mask tried to match the glow of numbers: a smooth tear with a long tail, a rounded bubble with a short wake, a lobal figure with two wings lifted at high latitude. The task was not to pick a favourite by grace, but to see which silhouette could wear the evidence without slipping. The heliosphere is a pressure balance, a wind-inflated cavity that pushes into a magnetized medium. Geometry is the language of that balance, and every instrument that listens to particles, fields, waves, and neutrals writes a syllable into its grammar. The classic drawing shows a comet-like body. In that portrait, the solar wind streams outward until it meets pressure from the local gas and field. Then it turns and is swept downstream into a single, soft tail. Flow dominates, magnetism yields. The shape pleases intuition because motion through a fluid often leaves a wake. Some evidence fits this mask. Particles energized near the termination shock can drift rearward, and simple models of ram pressure naturally form an extended tail. Yet the classic drawing encounters friction with facts when magnetic pressure outside rivals the flow. An elastic field can resist compression more stiffly than a river resists a stone. If elasticity commands, the shape must change. A second portrait is almost spherical. Here the outer field and the charge exchange between ions and neutrals combine to thicken the outer layers and drain momentum from the solar wind. The cavity ends in a squat back rather than a grand tail. Energetic neutral atom maps favor this view in some energy bands, showing a sky without a narrow, bright downstream filament. The absence of a sharp tail in those bands suggests that the wind may be mass-loaded and slowed so thoroughly that no long wake can survive. The field outside then drapes around a rounded obstacle, the way a sheet wraps a globe, producing the gentle magnetic alignment observed near the nose. This version of the mask wears the data well at the front and modestly at the flanks. A third mask lifts two lobes toward the poles. The idea is that the sun's own magnetic field can channel energetic particles and plasma into polar outflows that inflate high-latitude appendages, while the equatorial regions remain more compact. The result is a croissant-like figure, bulbous above and below, pinched near the midplane. Neutral atom images find arcs that could be the projected edges of such lobes. Particle gradients measured along latitudes hint at asymmetric thickness, with transitions below the plane sometimes tighter than those above. The two lobes also sit comfortably with the notion that external magnetic pressure sculpts as much as flow does, since a strong field pressing sideways can compress the equator while letting the poles expand. Each mask gains and loses ground as additional clues step forward. Energetic neutral atom imaging views the sky through conversions that occur where ions grab electrons from neutrals. Brightness depends on both plasma density and the rate of exchange. A tail could exist yet hide if it is cool, dilute, or poorly aligned with the line of sight to the detector. Conversely, a lack of a bright downstream stripe can be a true absence or a matter of contrast. The bubble mask remains plausible if the outer layers are so charged with neutrals that exchange smears out distinct features. The comet mask stays alive if there is a narrow energy band where the tail shines that has not yet been imaged deeply enough. The lobal mask thrives when arcs align with high-latitude enhancements that persist across solar cycles. Magnetism tightens the casting. If external field strength near the nose approaches half a nanotesla, magnetic tension can exceed the push of the local flow. In that regime, streamlines deflect earlier and more gently, and the obstacle prefers symmetry along the field axis rather than along the direction of motion alone. The draping then produces a nose that is flattened and a flank that is thickened. A long, thin tail becomes harder to sustain, especially if charge exchange robs energy continually from ions as they try to stream backward. The bubble and the lobes agree with this script. The comet does not vanish, but it must be compact and broad rather than narrow and endless. Charge exchange is a sculptor that does not tire. Fast ions from the solar wind trade electrons with slow neutrals drifting in from the galaxy, altering mass and momentum on both sides of the skin. As the trades accumulate, the wind grows heavier and cooler, the sheath thickens, and the transition spreads across tens of astronomical units. In such a layered border, a single tail can be swallowed by diffuse outflow. If polar channels exist, they can be fed by pickup ions that gyrate along the sun's field and find easier escape along high-latitude lines. The lobal mask benefits from this plumbing. The bubble still fits, with the caveat that the back may be rough with faint currents rather than perfectly smooth. Measurements of the termination shock distance add contour. When the shock sits closer in along one latitude than another, the downstream sheath thickness will differ around the compass. One spacecraft encountered the shock at a smaller radius than the other. The asymmetry points to pressure variations that distort the cavity. A stronger external field, tilted relative to the flow, can press one side, lifting the opposite shoulder. A lobal figure absorbs such asymmetry without strain. A perfect comet would need a reason to pinch and puff unevenly. A round bubble can handle the distortion if magnetic pressure dominates the script and slowly squeezes one quadrant more than others. The question of a bow feature influences the back. A fast obstacle in a compressible medium throws a shock. A gentler motion through a stiff, magnetized gas raises a bow wave instead, a gradual swell of compression without a discontinuity. Ultraviolet observations of piled hydrogen and the calm temperature structure inferred near the nose favor a wave. With a wave, the drape is tidy and the deflection of flow is smooth. A clean, undisturbed tail is less likely when the obstacle is mainly mass-loaded and turned aside gently. The bubble and lobal masks again hold their ground. The comet mask must shorten and broaden its wake to keep faith. Anisotropies in cosmic ray arrival directions act like charcoal shading on the sculpture. Outside the cavity, small preferences can reflect field geometry. If the field wraps around the bubble, longer mean free paths may align with certain arcs. Detectors found anisotropies that relaxed with distance while preserving a bias consistent with draped lines. This supports a nose where field lines lie nearly tangent and a body that is smoother than a bristled wake would be. A long, narrow tail with strong internal structure would likely imprint persistent, directional quirks that do not fade so gently. Their absence helps retire the grand tail from front stage. Dust distribution plays the role of fine relief. Charged grains ride the electric and magnetic environment with inertia that ions and electrons do not share. Filtering at the boundary adjusts which sizes and charges pass inward. Subtle changes in dust strike rates and signatures with distance hint at a mesh that is more uniform around a rounded or lobal back than around a comet's narrow tail where focusing and defocusing could be strong. The hints are modest and require care, yet they add a stroke of support to shapes that avoid thin funnels. Solar cycle phase writes transient makeup onto the masks. During maxima, the sun's field reverses and the sector pattern becomes more chaotic. During minima, Order returns. The sheath swells and shrinks, reconnection patches appear and subside, and the thickness of the outer layers changes by meaningful amounts. A true comet with a long, steady tail would be less sensitive to these rhythms than a bubble that breathes or a lobal figure that swells with changing polar outflows. Observations of boundary distances that shift by a few astronomical units and transition steepness that changes with epoch suit a living bubble or a crescent-like object. They do not applaud an unmoved stream. Simulations knit the hints into prototypes. Global magneto-hydrodynamic runs, enriched with charge exchange and pressure from suprathermal particles, construct cavities whose shape depends on the external field's direction, the speed of the interstellar flow, and the star's wind power. Many of these runs find short wakes and swollen noses when magnetic pressure dominates. When field lines channel polar outflows, lobes rise naturally. When the external field is weak and flows strong, longer tails appear but remain blunted by mass loading. Synthetic neutral atom maps drawn from the simulations can be compared with real maps. Those that include polar expansion and a strong drape best reproduce the observed arcs. Those that insist on a narrow tail find themselves flatter than the sky they hope to emulate. The conclusion is not a proclamation but a preference backed by converging lines. The heliosphere likely wears a rounded nose, set by magnetic draping, carries a back that is short and diffuse rather than infinitely trailing, and lifts high latitude lobes, inflated by flows guided along the sun's own field. The exact proportions are still debated, and the costume changes with the cycle and with the patchwork of the local medium. Yet the broad cut of the garment has become clear. The home of the planets is not a comet shot through the galaxy with a streamer that never ends. It is a pressurized sculpture, elastic at the front, braided along the skin, and broader at the poles where channels give the wind room to breathe. A shape is more than an outline. It is a summary of forces. The one that fits the evidence says that magnetism outside reinscribes the solar wind's ambition, that neutral atoms soften and thicken the edge, and that polar geometry matters. This shape explains why a compass reads a familiar bearing while reporting a stronger hand, why density rises calmly, why neutral atom images glow in arcs instead of streaks, and why crossings at different latitudes wear different accents. Geometry becomes meaning. The sun wears a form that admits the galaxy's pressure without surrender, and the galaxy accommodates a star that insists on breathing into it. Between them a figure stands, not rigid, not formless, but alive to the soft rules of a thin magnetic sea. Listening became the mission when the lights dimmed. The power that once fed cameras went to ears and clocks. A transmitter driven by warm stones of plutonium sent a carrier that faded a little each year, and a chorus of instruments learned to speak in fewer bits. The spacecraft kept its dish at Earth, with tiny murmurs of hydrazine and the quiet talk of reaction wheels. It lived by a routine that looked like prayer from far away. Point, measure, store, turn, speak, sleep. In that routine, sound replaced sight as the primary sense. Not sound in air, but sound as frequency, pitch, and timing. Plasma waves became music. The galaxy turned into an instrument. The antennas that served as ears were simple wires stretched outward from the bus. When shocks from solar eruptions arrived after their long march, electrons in the surrounding plasma oscillated at a frequency fixed by density. The wires felt the oscillation and delivered a tone. Frequency maps to number, just as surely as temperature maps to color. Analysts on Earth converted hertz into electrons per cubic centimeter and placed another dot on a graph. The dots ordered themselves along a slope that rose with distance. The slope wrote a melody. Rising notes meant a path into denser interstellar gas near the nose of the sun's bubble. Level notes meant a calmer stretch. Each note stayed in the record with a timestamp that made distance audible. Timing carried information beyond the notes themselves. A shock leaves the sun and races outward, changing as it goes. When its echo finally rings the distant plasma, the delay encodes the stiffness of everything in between. A stiffer medium transmits ripples faster, a softer one slows them. The cadence of tones arriving at the spacecraft let modelers back out how the heliosheath and the region outside responded to long-period forcing. In quiet seasons, the cadence stretched and the tones softened, as if the instrument were detuned. In active seasons, the sequence condensed and the tones sharpened. The ear replaced the eye and gained a ruler. Carrier waves turned into rulers too. The downlink was a narrow needle of radio that crossed the void and sank into the dishes of the deep space network. Its phase told velocity by Doppler shift. Its subtle twitches told attitude by polarization. Navigation teams fed the carrier into delta differential one-way ranging, a technique that compares the phase of the received tone against a reference quasar. The difference, minute and precise, stitched the craft's position to a web of distant radio points that do not move. The same carrier flickered through interplanetary scintillation, a small shimmering caused by plasma irregularities along the line of sight. Those flickers, once the noise to be removed, became data themselves when catalogued over months. They marked the state of the medium between stars as surely as starlight twinkling marks Earth's air. Listening to the carrier, listening to space, turned the spacecraft into a probe of everything it did not touch. Power management became a scientific process of its own. As the radioisotope generators cooled, heaters winked off, and instruments took turns. The magnetometer asked for minutes at full cadence, then yielded. The particle detector gathered spectra in longer integrations to conserve bits. The plasma wave instrument kept a sparse schedule timed to coincide with expected shock arrivals. Engineers balanced voltages as if tending candle flames in a draft. Each scheduling choice affected what could be learned. When a heater slept, an instrument's baseline shifted. Calibration tables evolved to subtract the new cold whisper while preserving the sky's voice. The discipline was not just survival, it was metrology under constraint. Software aged with grace. A memory patch rewrote a routine so that a stuck word would not crash a subsystem. Compression tables were updated to match the changing statistics of data types. Autonomy widened as light time grew. Commands sent from Earth had to imagine the craft's state hours ahead and include contingencies that would let it recover from small surprises while it flew beyond reach of quick correction. A watchdog timer guarded against silence. If an instrument lingered in a state that made no sense, a small logic would reset it gently. These habits of survival became part of the measurement because they determined which minutes could be sampled, which channels could speak, and which gaps would be permanent. The Deep Space Network adjusted in sympathy. Dishes arrayed together to catch a carrier now reduced to a ghost. Receivers cooled their front ends to squeeze noise out of the band. Frequency standards kept time with a stability that made the universe's stillness measurable. Operators scheduled windows that stacked across continents to hold the link while Earth turned. Each pass delivered packets that contained not only science, but health. Temperatures, voltages, switch states, counters, those housekeeping numbers were another kind of listening. A slow drift in an oscillator meant a component's thermal environment had changed. A rise in bit error rates meant the radiation rain had thickened. The spacecraft's own frailty became a dosimeter, registering the climate of the deep. Across years, the listening produced a logbook of tones that tracked the density along a single outward line. The logbook showed periods when shocks arrived in clusters, ringing the plasma repeatedly, and periods when the notes were sparse. The clusters coincided with storms launched at the sun long before, the sparse periods with quiet stellar weather. The relation was never perfect. Some shocks steepened and dissipated before crossing the boundary. Others threaded reconnection lanes and reached farther than their kin. The variance taught humility to prediction and gave value to the next tone, which could confirm or complicate an elegant forecast. The particle detectors continued their quiet labor, gathering counts that had to be posted like entries in a ledger. Their sensitivity to low energies made them windows into the near environment. When counts at the lowest bands rose or fell by small amounts, analysts asked whether the change belonged to the galaxy's weather or to an alteration in how particles threaded the local field. Comparing count changes with the pitch angle distribution of arrivals separated topology from climate. A shift toward more arrivals along the field implied a connectivity change. A uniform increase implied a true modulation of the source population. Listening across years turned these small discriminations from guesses into habits. Dust strikes added percussion to the score. Each tiny impact sent a pulse down the antennas that registered as a click. The rate of those clicks, corrected for geometry and speed, told the number of grains per volume and hinted at their size. A slow change in rate indicated the sieve at the solar border doing its work. When a brief spike appeared, the team checked for a cometary stream or for the passage through a faint filament of dust that wandered along a different plane. The dust channel grew thinner with age as the instruments cooled, yet every click counted. In a region so empty that a breath would disperse across a planet, even rare taps marked structure. The mission's cadence now matched the slowness of the medium. A single new tone could define a month. A small shift in cosmic ray anisotropy could define a season. The spacecraft's round-trip light time became a calendar of its own. Commands sent today would shape a report from a week that could no longer be touched. Analysts adapted by staging their questions. They asked first what the medium had done at the largest scales, then waited for the next pass to probe a smaller effect. Patience, already a requirement, matured into a method. Uncertainty narrowed not by sudden revelation but by the gentle pressure of consistent listening. In the quiet intervals between scheduled tones, background wave power told its own story. The spectrum of that hum revealed whether compressive or transverse fluctuations ruled. When compressive power rose, density variations grew stronger. When transverse power rose, tension waves carried the energy. The balance drifted with time. That drift, plotted alongside particle transport properties, showed how turbulence outside edits the passage of charged messengers. The ear that had been built to hear shocks became, in its old age, a stethoscope for the steady heart of interstellar space. The most human measure was the persistence of the link itself. Each pass through the sky with the big dishes confirmed that a voice at the edge could still find home. The engineering comfort of carrier lock and bit sync hid a deeper fact. A system designed in a century of tinny televisions and magnetic tape had learned to keep company with a galaxy. It did so by lowering its ambitions toward elegance and raising its ambition toward constancy. Less became more. Fewer channels, longer averages, slower cadences, each choice exchanged spectacle for certainty. Listening across the years turned distance into a knowable quantity. The gradient of plasma density became a slope in time. The elasticity of the boundary became the spacing of tones. The permeability of magnetism became a slow evolution of particle preferences. Even silence became a datum when a predicted tone did not arrive. That absence said that a shock had dissipated, or that the skin had shifted into a configuration that barred passage. The experiment lived as a conversation between an aging machine and a medium that rarely raised its voice. Plans grew from this conversation. New instruments are being designed with ears more sensitive, with clocks more stable, and with transmitters that can be heard by smaller dishes. A future craft may carry a receiver that can listen to the very carrier of its predecessor and use the flicker as a probe. Another may release small independent sensors to sample along multiple chords, turning a monologue into a choir. The path has been set by the old traveler's patience. It proved that the interstellar medium can be timed, mapped, and understood with instruments that prize longevity over spectacle. What remains most striking is the discipline of attention. The numbers that carry the frontier's character arrive as gentle variations. They can be lost in hurry. The team that listens moves at the pace of what they study. The craft keeps its own steady clock. The sun sends disturbances that the edge receives years later. The galaxy offers a constant reign whose fluctuations are measured in decimals. From this, slowness emerges clarity. Distance is not conquered. It is learned by listening long enough for the faintest tones to become a scale, and for the scale to become a song that an entire species can hum. Testing a boundary that no eye can see begins by multiplying vantage points. One instrument riding a single chord gives biography. Many chords build a chart. Arrays on Earth watch the cosmic ray rain for subtle seasons, tallying counts from polar stations and equatorial domes to recover the shield's global breathing. Spaceborne spectrometers in low orbit dissect the composition and energy of those messengers, feeding models that must continue outward to match the cleaner spectra beyond the bubble. Together, ground and orbit become a long baseline interferometer for particles, measuring not angle but modulation, not brightness, but the gentleness of a filter that a star keeps around itself. Radio observatories tilt their dishes to the lowest usable frequencies and listen for the slow hiss of space. Scintillation of distant quasars provides a survey of plasma irregularities all along the line of sight, turning twinkle into a tomographic hint of density and turbulence. Where the hiss strengthens, compressive modes hold sway. Where it softens, tension waves carry the sound. Records over years teach which latitudes above the sun's head prefer which kind of wave. These preferences trace the drape of the external magnetic field without touching it, a cartography drawn from how the universe flickers when it whispers. Closer to the star, craft that skim the inner wind reveal how turbulence is born, how sectors are braided, and how charge is partitioned long before the outflow meets the galaxy. The way that energy is injected near the source decides how it will cascade outward, which in turn sets the spectrum of fluctuations at the edge, where drapes form and reconnection patches bloom. Probes that sample within a few solar radii measure distribution functions at scales where particles actually trade their energy and pitch angles, allowing theory to lift kinetic rules into models that otherwise treat the plasma as a smooth fluid. When those rules are marched outward, they anchor the coefficients that govern diffusion, drifts, and waves at the frontier. Neutral atom imagers continue their skyward archaeology, watching the globe of space for arcs of glow where ions trade electrons with neutrals. Next-generation versions promise finer energy discrimination and faster cadence, erasing ambiguities between slowly fading arcs and swiftly changing ribbons. As these cameras stare across seasons of the star, they will catch the skin of the bubble heaving with the cycle, tensing as the field reverses, and relaxing as order returns. Models remain ready to turn those patterns into pressures and topologies. Where the maps brighten near high latitudes, they will weigh the plausibility of twin lobes. Where they dim near the tail, they will test whether wake really dwindles into diffuse drift. A future quiet ear may rise on the far side of the moon, a place where Earth's radio noise never reaches. At kilohertz and below, the ionosphere blinds every ground telescope. A small forest of antennas in that lunar night could listen to the background of the galaxy directly and hear whether the interstellar medium near the sun ever sings in its own right. Not only when shocked by eruptions, such an ear could calibrate the plasma wave tones recorded by travelers and remove the last doubt about density at the very lowest frequencies. It would also examine the long wavelength signatures of reconnection and other boundary processes that are too faint for noisier skies. Cosmic ray arrays on the ground, from alpine plateaus to polar ice escapes, refine their statistics and their stability. They can watch for minute changes in anisotropy that might mark a shift in the drape near the nose, or an altered transparency along a corridor opened by reconnection. When such a hint appears, analysts compare it to the clocks that record solar eruptions and to the neutral atom maps that light up interaction zones. Cross-correlation becomes the new telescope. No single eye resolves the frontier, but a chorus of instruments can triangulate its mood. Dust is its own messenger, and missions that weigh grains with time-of-flight spectrometers continue to pass through the outer system. By capturing speeds, charges, and compositions, they refine the siev's mesh at the border and teach how charged grains align with or resist magnetic shepherding. Planned analyzers will resolve isotopes within those grains, revealing whether some families originate in the local interstellar cloud or from farther afield. Subtle biases in which grains penetrate will then be traced back to local field geometry, turning collisions into compasses. Astrophysical context comes from beyond the sun entirely. Surveys of nearby stars catch excess absorption in the same ultraviolet line that marks hydrogen piled near the bubble. Those signatures set a comparative stage. If a cool red dwarf with a weak wind shows a thin ridge, while a younger, faster rotator carries a bright one, models that scale wind power against stellar age will be vindicated. The sun will find its place in a sequence, and the numbers that describe its skin will stop being provincial facts and become points on a curve that a galaxy of astrospheres must follow. Simulations stand between instruments like an interpreter. Global magnetohydrodynamic runs now braid together the star's wind, the interstellar flow, charge exchange, and the pressure of suprathermal particles. They evolve the shape of the bubble under a moving external field, a variable density cloud, and the flip of the star's magnetic polarity. Inside the skin, kinetic submodels handle reconnection and micro-instabilities. The simulations generate synthetic neutral atom skies, particle spectra at imaginary probes, and magnetic profiles along arbitrary chords. Every new dataset tests these virtual heliospheres. A fit is never declared complete. Instead, the code is taught to admit what it cannot yet predict and to ask for the measurement that would break a lingering degeneracy. A concept that once sat in a sketchbook has matured into a study with a manifesto. An interstellar probe, designed for speed and longevity, could reach several hundred astronomical units within a human generation. A heavy lifter would hurl it outward. A gravity assist at a giant planet would bend and accelerate its course. The payload would be sparse but decisive. A plasma instrument with full angular coverage, a magnetometer with fault-tolerant calibration, neutral atom imagers capable of viewing the bubble from the outside looking in, a dust analyzer with high charge resolution, and perhaps a compact radio telescope that can listen below terrestrial cutoffs. The craft would not merely cross a boundary. It would map the skin's global weather, chart the profile of the nose, and sweep the flanks where theory argues over lobes. Power remains the constraint. Radioisotope generators must deliver enough watts to keep instruments warm and speaking for decades. Thermal designs must embargo heat for the times when the sun's warmth is no longer a help but a memory. Autonomy must broaden so that a probe can choose with clear rules which events to sample at high cadence and which to average, because light time will make persuasion slow. The communication system will need gain born of discipline rather than mass, perhaps with phased arrays that can reconfigure as components age. Engineering does not follow science in this plan. It leads, because the question is not whether to listen, but how to listen long enough. A second path is to release scouts. Small probes, spun off along the way, could sample at different latitudes and longitudes, each a point moving through the same weather but at a different address. The main craft would act as a mothership and a relay. With even 2 or 3 scouts, topology would cease to be guessed from a single narrative and become a triangulated portrait. If one scout recorded a reconnection burst while another did not, the scale of such patches could be constrained directly. If density climbs steeply for the central craft and gently for a scout, the gradient's curvature would be measured rather than inferred. Questions guide these plans like stars for navigation. What fraction of the frontier is connected at any hour? How thick is the region where properties blend rather than swap? Where exactly does the drape change from tangent near the nose to a different alignment toward the flanks? How often do flux ropes peel from the skin, and how far do they drift before dissolving? How do dust and neutrals alter reconnection onset? How does the shield against cosmic rays depend on latitude when the star is quiet and when it is fierce? Each question can be written as an observable that a specific instrument can answer if given time, cadence, and power. None of these tests requires conquest. They require patience and triangulation. Instruments near the sun teach the seed of turbulence. Imagers near Earth paint the skin. Arrays on the ground count the rain that passes through the filter. A traveler in the outer dark writes the local weather into a ledger of tones, counts, and vectors. A probe farther out will turn that ledger into a map by drawing the contours that connect the scattered points. The result will not only be a shape, it will be a method for reading how a star belongs to its neighborhood. Beyond practical knowledge lies a quiet motive. To test a border is to test the idea that nature's negotiations can be measured into understanding. A star inflates a cavity, a galaxy presses back. The interface does not shout. It changes slowly. It prefers gradients to cliffs, and it leaves clues for any ear that can wait. The instruments being prepared are ears that expect to wait. Their reward will be a frontier no longer guessed by analogy, but described as carefully as any coastline drawn by a patient hand at the end of a long voyage. Outside is not absence. It is a grammar large enough to hold a star without flattery. A small machine moving outward measured that grammar in densities that rise by tender steps, in magnetic lines that choose patience over bravado, in particles that arrive from distances that do not care for human calendars. From those measures grew a meaning. The meaning is kinship. A star is not an island. It is a conversation partner, speaking with a wind, listening with a skin, and learning the slow dialect of the space that receives it. Consider the modest fact that the galaxy shines without a lamp. The shine here is not light. It is pressure from a field that cannot be seen, temperature from a gas too thin to breathe, and a rain of particles whose stories began with explosions that burned long before the first stories on a particular world were told. A star enters that shine as a guest who brings a gift. The gift is a wind that inflates a room and makes a shelter for planets. The shelter is a kindness with limits. At the edge, the wind's courtesy meets the galaxy's courtesy, and neither bows completely. Etiquette becomes physics. The two airs mingle without scandal, exchange a little momentum, trade a few charges, and find a shape they can share. Meaning hides in this restraint. If emptiness had ruled, a boundary would be a line without texture. The numbers would be zeros. There would be no patience required to hear a tone rise in pitch as distance grows. Instead, the edge offers texture with a light hand. Density is small, yet it changes. Magnetism is weak, yet it chooses direction with resolve. Radiation is subtle, yet it shapes risk and chemistry far inside the bubble. The modesty is the lesson. The universe does not need spectacle to govern. It governs by balance sheets written in rarefied ink. The word outside suggests exile. The measurements answer with belonging. Gravity keeps the traveler in the star's company, even as it sails across a medium that owes nothing to that star. Light from the sun continues to fall across the hull, though thin and old by the time it arrives. The local field wraps around the cavity as if to greet an object that has always been there. Nothing in the record speaks of banishment. Everything speaks of membership in a neighborhood that includes both the bubble and the drift that surrounds it. This membership has consequences that reach inward toward worlds that bloom and cool and bloom again. The shield laid down by a star's wind edits the galaxy's reign. That edit is as practical as a roof. It changes the dose that a cell must endure far from home. It changes the reliability that a memory must protect inside a chip. It changes the rate at which a high atmosphere grows. Ion pairs that seed chemistry. It follows then that belonging is protective. To live under a star is to share in the geometry of kindness that its wind can afford. To go beyond is to enter the climate from which that kindness was carved. Belonging also has a mirror. The galaxy is not a background. It is an active host that presses back with a field that remembers supernovae, with neutrals that remember the cold patience of clouds, with turbulence that remembers a cascade from scales too vast to imagine. The bubble that a star inflates is shaped by that host. The nose flattens where the field is firm, the flanks swell where pressure is gentle, the back lifts where polar flows find the fewest obstacles. The star writes the first draft of its space. The host edits. If the host's pen angles change, the draft changes. This is not erasure, it is collaboration. Listening to the outside taught humility about prediction. A boundary can be both permeable and firm, both aligned and restless, both simple in long averages and knotty in minutes. The outside invites models to admit more than one cause when faced with one effect. A rise in density can signal a gradual stagnation near the nose, an echo of a passing shock, or an approach to a filament of stronger field. A small rotation in magnetism can name the passage of a reconnected island or the ghost of a sector that left the sun a decade earlier. Truth is plural without becoming vague. Each contributing process leaves a different cadence and a different correlation. The patient ear can tell them apart. The philosophy of this listening is not grand. It is a craft. The craft insists that borders are built from relationships rather than from cliffs. The craft refuses the romance of a single sign and asks for a chorus. The craft turns patience into a unit of measure. Something similar holds in every scale that nature grants. A coastline is not a line when seen from the beach. It is tide and wind and geology negotiating one another into a place that looks different by season and hour. So the edge of a star, when seen closely enough, looks alive without being capricious. Outside also refines language. The word frontier carries the weight of conquest in some histories. Here the word keeps only its map-making. No land is taken, no path is fenced. The act is to translate a gradient into understanding. Translation honors both sides. The star keeps breathing, the galaxy keeps pressing. The result is a shape that evolves without apology. In such a practice, curiosity replaces rivalry. The traveler that measures does not alter what it measures, except to add the smallest heat from a whisper of electricity. It merely listens and relays. To choose listening as the method is to choose a respect that suits the scale. The measurements restore wonder without forcing myth. A tone in a radio receiver says that electrons nearby have begun to ring. The pitch of that ring yields a density that could be written on a napkin. From that napkin grows a claim about the stiffness of a medium thought by many to be empty. A curve of count says that cosmic rays arrive more freely outside than in. From that curve grows a better plan for humans who wish to travel beyond their cushion. A compass needle that leans in one direction and not another says that the outside's field prefers a certain alignment near the nose. From that leaning grows a portrait of a bubble pressed by elastic hands. None of these steps asks for faith. All ask for care. Meaning becomes tender when placed beside time. The crossing of a boundary is a moment in a human life, but a blink in the story of a star and a pause in the story of a galaxy. The road ahead of the traveler is longer than the present memory of its makers. The reports that still arrive are gifts from an earlier ambition, kept alive by engineers and listeners who inherit a duty to the patient. The duty is beautiful. It says that knowledge can outlast the budgets and fashions that once lifted it. It says that a species can learn from instruments that have no pride, and from spaces that have no anger. There is an intimacy in this grandness. The last photons that carry a data frame to a dish in the night are cousins of the photons that warmed the first oceans on a warm world. The magnetic field that stabilizes a boundary is kin to the fields that swirl inside a human heart monitor. The cosmic rays that count themselves on a detector have distant siblings in the same rain that carves micro scars in rooftop panels. Outside is not remote when seen in this braid. It threads through everything near. It is written in the quiet arithmetic that binds lives to the space that hosts them. What was discovered, finally, is that outside belongs in the same sentence as home. Home is not a wall around a star. Home is a continuity that runs from a fusion core to a draped skin to a neighborly medium and beyond, each region different, each region exchanging what it can with what surrounds it. The meaning of outside is the meaning of relationship. Nothing in the measurements scolds boldness or ambition. They ask instead that boldness be paired with patience and that ambition be paired with listening. The rest is distance and the refusal to be hurried by it. The galaxy is not a vacuum with decorations. It is a place. It keeps a weather. It answers gently to a star's breath and speaks with a voice that registers as a shift of pitch in a receiver at the end of a wire. A traveler heard that voice, counted its inflections, and sent the counts home. The counts became a map. The map became a mirror. The mirror showed a species its true size in a kind way. Small, yes, but capable of listening across a day of light travel and making meaning from whispers. Outside is not exile. It is the larger room into which home opens when curiosity turns the handle and steps through. Night gathers along the curved lip of a dish. Receivers cool to a hush that could be mistaken for sleep if sleep had a clock as steady. Far away, a carrier laces the darkness with a line so thin that it feels like a thought. Past planets that shine with borrowed light, past the ice where sunlight is rumor, past the boundary where the sun's breath meets the gentleness of a wider patience, the little signal continues. It is not a shout. It is a heartbeat that refuses to forget. In that pulse is the measure of a long kindness. A star builds a shelter. The shelter filters an ancient rain. Beyond the shelter, the rain steadies and the field chooses a bearing that does not ask to be seen. Everything here works with small forces stretched across long times. That may be the truest poetry in physics. Where power is thin, persistence matters more than power. Where distance is vast, attention becomes the only engine that never runs out. Imagine a hand on a railing at dawn, feeling the swell and dip of a sea that can only be known by touch. The Voyager is that hand. The sea is a galaxy that keeps its promises softly. There will be other hands one day, a faster craft with a longer memory, a quiet ear on the lunar night, small scouts that taste the border at different addresses. Each will add another bar to the slow music that has begun. None will replace the first note. A light that left the sun many hours ago touches the hull and moves on. A clock ticks. An antenna turns toward Earth as if toward an old friend standing very far down a path. The friend answers. The two keep the appointment they made a generation ago, and the world that built them listens. What they trade is not just data. It is the proof that patience can carry meaning across empty miles and return with more than it took. End of script. Sweet dreams.